you have components that maybe interact with the DOM API. So for some reason, maybe the card component uses .query selector all or any of the DOM APIs that we usually see. Or maybe the card component has some sort of a lifecycle method, a React lifecycle method that you want to test, such as component did mount. Now, one note with the mount is that it requires a full DOM API to actually work and be available for us for the mount to happen. And this means that it has to run in an environment that at least looks like the browser environment. And if you remember from our previous talk, you might not always want to run your tests inside of a browser because, well, it takes a bit of time. So if you don't want to run your tests inside of a browser, you might use something like a headless browser or a JS DOM. And it's recommended that with JS DOM is used with mount. Keep that in mind. Mount, unlike shallow rendering, does a full render and actually mounts the component on a DOM, just like React does, which means that tests can affect each other if they're all using the same DOM. But like I said, it's very rare that you want to use mount because it can get complicated and you want to keep your tests as clean and contained as possible. Finally, the last one is the render. And the render function, as the name suggests, is used to render React components, but unlike to a real DOM, it's rendered to a static HTML. So render returns something very similar to what shallow and mount does. However, the difference is that render uses a library called Cheerio underneath the hood. Think of it as an in-between shallow and mount. It doesn't actually need a full DOM API, but it does render any of the card children underneath it if you need to test those. All right, so we have Enzyme set up and we can test some of our components, but there's still a little bit more work we need to do. So for that one, I'll see you in the next one. Bye-bye. Welcome back. If you remember our talk about testing, I mentioned that React has these two special features that you often see in their tests. One is the Enzyme library, which allows us to render our components in a test environment, which we saw. And then we can use whatever expect methods that we want from Jest to actually test whatever is rendered. But there's also another thing called the snapshot testing. And again, this is another really good tool that comes with Jest that really helps us test our React components. So let's talk about that in this video. If we go back to our app, you might be asking yourself, all right, I can keep going with this card component and just use the regular Jest syntax to make sure that the card component has everything that I need, including maybe an image tag, a div tag, some names and emails. But here's the thing. We worked really hard to keep these components what we call stateless components. They are not using the class syntax to extend React component. They don't have any state. They're just pure functions that we've created. So if we're actually writing tests, I bet we're going to repeat a lot of code here. We're always going to just be testing if this got rendered, if this got rendered. And that's a lot of repeated work for a developer. Well, Jest realized that this would be a lot of redundant, wasted time. Wouldn't it be great if we can just take a snapshot of whatever this card component renders, and anytime while we're writing our card component, anything changes and the component doesn't look as we expected it to, as the snapshot that we took a picture of, well, if it looks any different, then we failed the test. That's what snapshot testing is. And it's really easy. Let me demonstrate and you'll see how simple it is. Let's go back to our cart test here. Instead of doing the length to equal 1 and many other tests that we can write here, let's do something different here. I'm going to write expect. We're going to shallow card. And since we're not using render and mount here, let's just remove that from our imports. Now, we've rendered the card component. In Jest, we can use snapshot testing to say to match snapshot. That's it. So what does this do? Well, let's save here and see what just happened. We have a snapshot summary that showed up. It says one snapshot written in one test suite. And we see that it passed. That's good. But one thing you may have noticed is that we now have a folder, a snapshot folder, that magically appeared just by running this method. If I open this up, I see that Jest took a snapshot. And you can read up more about it here, but it looks like a text file, a plain text file, that has all these things. You see the shallow wrapper object here that has of length 1. It has the class name that we have in our div. If I keep scrolling down, we see that we have a ton of information, such as the type of div. We also have a type of P, a paragraph. Now, what does this actually mean? This took a picture of this component when we shallow rendered it, so that now I can keep saving. Let's say I'm working on my app, working on the card component, and I keep saving, but I decide to remove this text center tachyons class that it has. I'm going to change that and save that. Now my tests fail. And it says one snapshot test failed because we've just changed what the snapshot expected the card component to render. How cool is that? Magically detects any changes, and if, let's say, a developer comes in and messes up our card component, the test will immediately fail. We see that expect to render card component is failing. That's very, very cool, and it even tells you where the changes have been made. This is the same with, let's say, we're by mistake not rendering our P component, our email of the robot. If I save this, we see that we're missing a few things. Very cool. Now, let's go back to having the email here. Let's save it. Okay, everything is passing. But let's say that, well, I actually do now want the text to be centered. This was intentional. I did want to move the class name and make a change to it. Well, with snapshot testing, if I save this, we see that we have press W to show more. I'm going to press the W key. And here, we see that we have the option of pressing U to update the failing snapshots. If I press U here, it's going to take another snapshot, and it's going to say, yes, I made this intentionally, take another snapshot and use that as the reference. So I'm going to say U, and there you go. My snapshot is now updated. And if I go back to the way I had it before, it's not going to fail because it's expecting a different snapshot. The snapshot was just updated in here. Now, how simple is that? It's very, very nice. And as a matter of fact, because we've made this card component so simple, it's just a function, a pure function that takes an input and always produces the same output. By just using the snapshot testing, we don't really need to test anymore. We're testing exactly what it needs to do, which is make sure that the card component renders whatever we tell it to render. And that's the beauty of snapshot testing and creating these small stateless components. we can have really, really nice tests that are one-liners to just run a snapshot test. And we've pretty much covered our bases for the card. Now, one thing I haven't shown you, and let me go back to updating our snapshot here. I'm going to press U, is code coverage. How do we know that the map snapshot or the to-match snapshot is actually fully testing the card component? Well, I can run npm test space coverage, and it's going to show me a coverage report. And let me make this a little bit bigger so we can see. Look at that. We have absolutely 0 tests other than perhaps the setup test.js, but that's because we're not doing anything in that file. So there's not much to test there. But if we look at card component, even though all the other components have just 0% test coverage, card component now has 100% code coverage. How cool is that? One simple line, and we've covered our bases with the card component. Again, I'm going to keep saying this throughout these videos, but writing tests shouldn't be complicated. Try to structure your application in a way that writing tests are really, really simple. And the way you do that is by writing these pure functions that keep things simple, and you don't have these massive functions that do a ton of things that become harder and harder to test with more lines of code. All right, that's it for now. Let's keep writing some more tests in the next video. Bye-bye. Welcome back. Let's use snapshot testing to test some of these other simple presentational components that are completely stateless, since we saw how easy that is. So let me make this a little bit smaller and make sure we run npm test to have it running in the background. We see that our test or our card component is being tested now. So let's create another one. Let's create a test for the card list component. Now I'm going to remove the console log here because we don't need it. And let's create a cardlist.test file. So cardlist.test.js. And again, it's failing because we need to make sure we have at least a single test. We can actually go back to card.test.js and just copy and paste this, go to cardlist component, copy and paste whatever we had, and just change our component to card list. So let's just do that quickly. We can just select all of these and say card list. Let me save. And we have some fails here. Let's see why. We see that we get a type error, cannot read property map of undefined. And that is because card list, you see card component is just rendering name and email, but it's not doing anything to it. So if it doesn't get name and email, it'll just render undefined. When we go to card list, we see that we're actually receiving the robots and we need to map over them. But in our test, we're rendering card, or let's go to card list. I'm going to close this so we don't get confused. We're not passing down robots. So in this test, when we try and render card list, it's going to fail because there's no robots to map over. So let's fix that. All we need to do here is just mock our robots. So we can just say const robots, or let's just say mock robots, is going to equal an array of some dummy data that we can create. So let's say that this is going to have an ID of 1, and we'll have the name of Jon Snow. Let's say username is going to be John. And let's say that email, I don't think we're using your username, but I wanted to give that username anyway, is going to be john@gmail.com. Now we can just pass our mock robots as the robots prop. So let's see if that works. I'm going to save. All right, and we have our tests passing. And if we go to our snapshot, we see that we have a card list snapshot as well. That's good. Our test failed because we weren't passing robots, and well, we want to make sure that we actually pass those properties. And you can imagine you can probably do the same thing with card as well, or maybe have a default in this component where if you don't receive name, email, and ID, that it has some sort of an error boundary or an output that it does for the user. We now see the power of snapshot testing. We see how we can mock some of our properties, and you might want to just go ahead and do snapshot testing for some of these other cases that are quite simple to do to increase our test coverage. And I'm going to leave that up to you because, well, just to give you a bit of extra practice. So let's move on to the next video where we do some things that are a little bit more difficult. But just to check, let's do our coverage to make sure that our coverage for the card list is now looking good. I'm going to make this a little bit bigger. And we see that, yep, look at that. Feels good getting 100%, doesn't it? Card list component is now well tested as well. I'll see you in the next one. Bye-bye. Welcome back. Let's do some tests that are a little bit more difficult to do. If we make this a little bit smaller, let's just have npm run test, just to have it running in the background. That's always nice. And let's go into our card or counter button, because this is a little bit more unique, right? It's not a stateless component anymore. We actually have a state with the count, and yeah, we have a little bit more logic. We also have this set state that is happening where we increment our state count. And I think in the previous video, I had this as a separate method that you can call in here. For now, we can just leave it the way it is. The idea is that we want to test this state function, that it actually increments, because that's what you expect from a counter button. So how are we going to test that? As we know, the very first step is to actually create a test file. So let's say counter button .test.js. And the first thing we want to do, well, again, we've already kind of done this before, so I'm going to copy from the card list test. Let's close some of these just to clean things up. And copy and paste this. Now, instead of card list, we're testing the counter button. And we also don't really need our mock robots anymore. And this counter button doesn't have any props that it receives. Well, it has the color prop actually. So let's just do a const mock color. And we'll say that this mock color would just be red. And we'll give it a, make sure this is an actual component. We'll give it a color of mock color. Now, here's the thing. Even though it's a stateful component, we can still do match snapshot testing to it. I mean, it's still a component. So let's save. And now we have a new snapshot. Perfect. So if we ever modify counter button, it's going to error out. That's good. Let's make this a little bit smaller. All right, let's create another test in here. And by the way, if you want, you could use the describe and then group all the tests together. But I've already shown you how to do that. You can do that on your own if you want to have more organization for your tests. Let's have another test this time that we'll say we want to make sure that it correctly increments the counter. And again, our usual syntax, and in here we can write tests. So what can we do? Well, first things, let's just do a const wrapper, and this is just going to be the shallow rendering of our component. And we'll just have a mock color as well that we're going to use. All right, so now that we have this, instead of just always typing expect and then doing the shallow, we can just say expect wrapper, and we can write more tests that way. In here, let's say that we want to have wrapper.find. Another thing that we get with the enzyme package. So on the wrapper, just like we would in jQuery or query select all, we can do something like find, where we find, let's say, the ID, and this has to be square brackets actually, where we have ID of counter. By doing this, I can now go into my counter button and just give it an ID of counter. And we'll make sure that we make the snapshot pass. And now we can find this ID counter, which is the button now. And we can do something called simulate. And we can simulate an event, such as a click event, which our counter has, an on-click event. So we've just simulated a click on this counter button. So if we've simulated a click on the counter button and the state count, or the count in the state is 0, we expect the count now to be 1. So all we would need to do is say expect wrapper. We can use something called state. So this is going to grab the state, and we expect that state to equal count of 1. Let's see if that actually works. Let me add some semicolons here. All right. Everything is passing, but again, we want to make sure that it's actually testing what we want. Let's say this is 0 now. Oh, it's failed. And let's go back again just to make sure our thing passes. I'm going to simulate a click again. So if I go, nope, now it's expecting a count of 2. So I change this to 2, and our tests are passing. That's pretty cool. Now, if I remove this counter, and I have 2 failed tests now, because on top of running the snapshot, which fails now because we've changed the look of the component, we've also removed the way for us to grab that component by ID, and you can see that method simulate is only meant to be run on a single node, 0 found, because we weren't able to find the ID of counter. And you can do many things here to grab an object. I usually like having an ID because, well, it just reads nicely. But that's pretty cool, right? We just, in very simple way, tested our state. And once again, don't get overwhelmed by all this wording with the Jest cheat sheet and the enzyme documentation. You can pick this up in a day fairly easy. And I don't remember all of these. I usually go to their documentation and say, oh yeah, they have a simulate method. Oh yeah, they have the state method to grab the state. And that's how you work as a developer. You don't have an encyclopedia all in your head of all the methods. You just know that this is what enzyme and Jest do. Let me go check out their documentation and see how I can grab state. Oh, and by the way, if I add, again, remember, this is JavaScript. We're just going one by one. If I add here another click, and at the bottom here, I run another expect, I'm going to expect that it's now a 3. And you see that all my tests still pass because everything happens sequentially. And if I add another click here, then I can, or let's say this one is going to be a key press. Even if there's a key press on there, because there's no key press event, I still expect the state of count to equal 3. There you go. Now, when you're testing, there's so many things that you can test for. You can just keep going and keep going and keep going. But you want to use your time wisely. Does this test, is it enough to move on to other tests? And it's always a trade-off on how your project is doing, how much other tests your project have, and how much time and resources you have to write tests. Let's do one last one. I'm going to expect that the wrapper dot props to, let's say, to equal, let's say, color red. Let's see if that works. All right, I got a failed test, and that's because I was just kind of guessing based on state whether it has the props and to equal. So let's scroll up, and we see that we expected color red, but instead we got a ton of other props because, well, we have color red, but we also get children, and we also have ID as well as the onClick event. Another thing we can do here is perhaps just do color. Let's save. And now we get red, which is good. So we want to say to equal red. And there you go. Our test pass. We do have a console log here, which is kind of annoying. So let's remove that from the counter button. And there you go. Our tests are passing and looking very, very nice. I hope that you got a general idea of how to test components. And by the way, this snapshot folder, you're going to actually include that in your GitHub or whatever source control you have. You're going to push that and commit it to your project, because any new developer that comes onto the project is going to download the latest master. And you also want to make sure that they have these snapshots, so when they run the tests and they modify a component, these snapshots are going to check against the old version and make sure that this new developer doesn't change anything. So again, these things are also going to go into your source control or version control. All right, I'll see you in the next video. Bye-bye. Welcome back. I wanted to take a second here before we keep going with testing our RoboFriends app to just go over what we've learned from our slides and how it all makes sense now. We learned that now we have Jest that we can install that provides for us a test framework, something that we can run tests in. And this Jest also comes with an assertion library where we can use expect dot to be equal or to have, or all these things that we can do that we saw in our cheat sheet to assert something, to make sure that this equals this. And then we also saw that Jest comes with a test runner, something that we're able to run the test in. And you saw that in my terminal, I always have those tests running and checking and making sure that things are always passing. We also saw that we have mocking functions that we can use. We saw that in our example where we built our Star Wars API, where we got all those people, that we could mock the fetch function and make sure that it was called. Again, something that comes with Jest. Sign-on is another popular one that it works very, very similar that you're going to see as well. And then finally, we saw that we can do code coverage by running npm test -- coverage. And it gives us a coverage of where we have tests and where we don't, so that we can improve our app. I told you this is going to make sense, and we're not even done yet. We saw that we can test our app programmatically. But if we need any time to use some DOM APIs, we have those three options. We can use the actual DOM. We can use something like Puppeteer for a headless browser, or something like JS DOM, which if we're using the mount rendering in Enzyme, we can set up as well. Again, this setup is fairly simple, and you can check it out on the Enzyme documentation. Oh yeah, and we also learned that in React, we can use Enzyme and snapshot testing to make our tests super, super easy. Again, another reason that I love using Jest, especially with React projects. That was a quick break. Back to coding we go in the next video. See you in that one. Bye-bye. All right, we're starting to write more and more tests, but up until now, we've only worked with some simple components. What if we want to work with something like a container that app.js is? We have all this map state to props. It's also a connected component. How do we test with that? Let's give it a try. I'm going to create a new file and call it app.test.js. And this app.test.js, again, we can just go through the motions and copy one of the last tests. Let's just do this. And this time, instead of counter button, it's going to be app. And again, we won't receive any colors. Let's just run this and see what happens. Oh, actually, let me delete this as well. Save. All right, I'm getting some errors. It says expect to render app component, which is over here. But I'm getting an error saying that invariant violation could not find store in either the context or props of connect app. All right, so let's just mock a store. We can say const mock store equals, let's say, an empty object for now. Or let's just do the robots of an empty array, and let's do search term or a search field that is an empty string. And we'll just pass this mock store as the store prop. Let's save. And oh boy, I'm getting store.getState is not a function. And that makes sense, right? If you remember, our store isn't just an empty object or a dummy object. I mean, it is in Redux terms, but it also came with all these other things that we didn't really think about when we installed Redux. We had getState, subscribe, and all these other methods that came with it. So that means we have to mock this entire list of store methods that Redux comes up with. And if Redux updates and adds something new in the future, well, we're going to have to update that as well. And luckily for us, there's tools that already do this for you. For example, there's a package called Redux mock store that you can use to actually mock this store and have these proper methods on it. And that's an npm package that we can install. But I want to take a different route. I want to take a route of simplicity. Because right now, looking at this app.js file, we're doing a lot of things. And I like simple tests. Tests that test simple things. And this app.js is frankly a little bit complicated because we have this connect. So it's technically not even rendering the app, it's rendering connect. And then that is wrapped by app. Let me show you what I mean. If I go back to our app and open up our React developer tools, you might have to download this plugin if you don't have it already. I see that my app is a provider and then a connect app. So this app, what we're actually testing is this connect component that is wrapping the app. And only inside of it, we have the app and then header, search box, scroll, and so on and so forth. Let's simplify this. Why not just test our app instead of testing our connected component? And this is what I like to do when I test things. Instead of trying to test a really complicated component, I ask myself, is this component as simple as it can be? Is there better things that I can do with code to make it more testable, which usually results in better code overall? So looking at this app component does two main things. One, it connects to the Redux store through all this map state to props and map dispatch to props, but it also renders a ton of these things. So let's separate this out. I'm going to create a new component file and call it main-page.js. So you can think of this as the homepage of our RoboFriends app. And now this main page will also have a test file. So I'm going to move the app.test.js to actually be renamed to main page and put it into the components folder. All right, our tests are failing, but that's because we have our names all off. So let's go about this step by step. Let's make app.js be worried about just connecting and receiving props from the store, and make our main page be concerned with rendering all this homepage stuff. So how can we do this? Well, the very first step is I'm going to copy the entire app.js file, go to our main page, copy and paste it, and right off the bat, remove all the Redux things because I don't need anything Redux. This is going to be a simple component that's not connected to a Redux store. So I'm going to remove the connect. I'm going to remove any of the actions and just leave our components. I'm going to remove the map state to props, map dispatch to props. And I'm going to rename this to main page component. And we don't have a CSS file for it. Or maybe we should move this app.js to our main page. So for now, I'm just going to create something quickly. I'm going to say new file, mainpage.css. And by the way, you're starting to see why we might want to have a better folder structure than just files, files, files. We might want to have components and a component folder for each one of these components. And I'm just going to copy and paste here. And going back to our main page, we now have the CSS. We have the constructor. And I don't know why we have our count in here. I don't think we need the count. It's not using it at all. So let's just remove that. So we don't need a constructor. And in our main page, again, there's no constructor. We have the component did mount because, well, we want to request robots. And we have our regular render. But we also don't have our connect anymore. We're just simply rendering our main page. All right, so we've removed this and made this into a simple app that still has the component did mount, but that's just props that we received from the store. All right, so let's go into app.js and now remove the app part because we don't really need that anymore, or we don't need the render part. We just need the connected component. So again, in here now for our render, all we really need to do is, well, remove all of this. Feels nice removing stuff and making files smaller. And all we need is the main page component to render, right? So we can remove all these component imports and just import the main page component. Again, another reason I love React is everything is just so nice and simple to move components around. But look what we've just done really, really quickly. Oh, and we definitely don't need component did mount because we're doing that in the main page. So look how small that component just got. How nice is that? And now this app component just turned into a super simple container component. And this is an architectural decision that I really, really like because we don't really need to even test this, do we? Because all we're doing is just using the connect function to grab the state and dispatch events from our Redux store. So even writing tests for this, although we could do it, we're just simply testing the functionality of Redux. And that's something that Redux library already does. It already has tests and people working to make sure that it works properly. This component now becomes something so simple that we might not even need to test. And we've moved all our logic that we can test to the main page component. And that's something really important to think about, to always try and make your tests easy. If they're not, then perhaps there's something in your code that you can simplify. And you can see how elegant of a solution this is. The last thing we really want to do is just pass down these props down to the main page. To do that, we can just use some destructuring or object spread to say this dot props. Let's save. And I actually haven't tested this code, so make sure it still works. Let's run npm start. I'm sure there's something that we may have missed. Let's close this. All right, we have your render method should have a return statement. And yep, we need to actually return from this render statement. That's silly of us. Let's return. And we have a bit of an issue with the CSS, and that is because it can't find the Saga font. So that's a simple fix. We just go to the URL and do, because the Saga font is in the containers, we can just simply do containers for now, even though we probably want to move this around for now for demonstration purposes. That's fine. Everything is passing. If I go back, I see that there's a few other errors. We have the count of null, and we're passing the count state in here in the header component. But if you remember, our header component has the counter button that actually has its own state. So looks like we're doing this for no reason. So let's just remove that from the, where is it? From the main page.js. So we can just remove that, save, go back. All right, everything is working. Make sure our searching works. Yeah, everything is working. Count is working. If I open up my React developer tools, nope, not Redux. We want React. We have the provider. We have the connected app, but check this out. We now have the main page that we can test. And this main page now is more accessible for us using enzyme ingest. So let's write some tests here. We're going to go into the main page.tests. All right, let's first change the name to main page, which is what we're testing now. And because I feel like we're going to be doing this a lot and passing down some props, there's a neat little trick that we can do. Let's say we're going to have a let wrapper, and I'm going to remove this for now. And we can use something called before each. Again, comes with Jest and other testing frameworks. And this makes sure that it runs before each one of our tests. Now in here, we simply give it a function, And inside of this function, we can say what should run before each one of our tests. In our case, we want to mock props. And these mock props, well, what are we going to have? We're going to have the on request robots, which if you remember, let's close this and close this so it's a little bit cleaner. If you remember, main page has the on request robots function. So we can just do the jest function here, which we've seen before with mocking. So we're just saying that this is just a simple function. Don't worry about actually doing the API call. We'll say that robots is an empty array. That search field is going to be an empty string. And that is pending will be set to false. And then finally, because we have this for each or before each, we're going to say that the wrapper is going to equal the shallow rendered main page. And this main page, again, just like we did in our app.js, can just receive the props, that is the mock props. So this is going to receive all these properties just like we did in app.js. See that over here? All right, so let's save here. I'm going to go back to running npm test. And we have a few errors because, well, that's not semicolon, that's comma. My arch nemesis, the comma. And we get an error saying that our test suites must contain one test because we haven't written one yet. We just wrote the before each. Now, let's start off with the basics. It renders main page without crashing. And we'll say that, well, we can use our favorite test tool, snapshot testing. We can just say expect wrapper, because now we have access to this wrapper that is shallow rendered because before each is going to run before this test. And I'll say to match snapshot. I love how easy this is. Let's save. And what did I mess up here? Wow, I am terrible at writing commas. All right, there you go. You must be just laughing at me right now with all the commas that I miss while I code. But hey, we're all human here. We all make mistakes. I don't think there's ever a perfect developer that doesn't make mistakes while coding. If there are, well, I'm very jealous of them. All right, let's test another thing. Let's say that I wanted to make sure that it filters the robots correctly. So I'll say it filters robots correctly. And I'm just going to say that in here, we expect the wrapper. And how do we do this? If we go to mainpage.js, we have filter robots in here. But that's happening in the render function. So let's just clean this up and say that we have the filter robots. And this filter robots will receive the robots, and it's going to, well, let's make it an arrow function. And we can just grab this and just return our filtered robots. We're going to need the search field here. So I'm going to say this dot props dot search field to lowercase. And now within here, we can just say that filtered robots is coming from this dot filtered robots. Let's just make sure this runs. I'm going to go back and run npm start. And it looks like I made a mistake somewhere here. we need to actually pass down the robots. So let's just say it's going to receive the robots. Or we can even do this up over here. For now, let's just leave it like that and make sure we have our naming correct here. Filter robots. Let's go back. All right, it's still working. So now that I've made this a little bit cleaner in our render function, and let's just remove the search field from here. There you go. How can I actually test this? We can now just simply test this method on the main page class. Well, we can just now use the instance property that comes with Enzyme. And now this instance is going to give us access to all the methods that main page has, including filter robots. So let's say in our test, I'm going to move this around. I'm going to say dot filter robots. It's going to run filter robots with, let's say, an empty array. And we expect that to equal an empty array. So let's save and run npm start or npm test. We have a failed test. Oh, and I made a bit of a mistake here. The expect should be around this entire thing. We want to expect that the filter robots runs, and we want it to equal the empty array. Let's save. All right, everything is passing, but let's test other cases because, well, this is most likely not going to be the case. Let's say that this time around, in this statement only, even though we're getting the before each and we have access to the wrapper, this time around, we want to have a special case where the mock props is going to have a search field of A. And in here, we have a robot that is, let's say, ID 3 with a name of John and email. We'll leave username out of it for now. john@gmail.com. Let's save this and create a new expect statement now. And just for this test, we're going to use a different wrapper. So let's just say a wrapper with, and I know this is not the cleanest, but I'm trying to illustrate a point here, so bear with me. So let's do mock props 2, and this is going to be wrapper 2. So let's save wrapper 2, save. And it says filters robots correctly. And you know what? I just realized I think a better way for us to do filter robots, for now at least, is we can forget about the props and we can just do this dot props dot robots. So going back here, we can now remove these arrays, so it just looks a little bit cleaner. And let's make this test pass. We get a bit of an error here because we need to do const wrapper2 because wrapper is not defined. Remember, we have to define it. And our tests pass because our search field is A, and we only have robots with John and john@gmail.com. But if I change this to John, it fails because we expected to equal the actual robots with John in it. For now, we can just say that we expect this array to be returned, and I'm going to remove the first one. Let's save. Oh, and I have extra array brackets here. Again, this is good. Our tests are failing, and we're working towards passing them. All right, and now we know that filters robots correctly is working. And you can already start to see some things that we can clean up here. We can just copy and paste this. Let's just create one more instance and says filters robot correctly 2. We'll say that we'll say 3 for now just to keep this clean. We'll say that the const filter or filtered robots should equal an empty array. And this time we're searching for the letter A, which doesn't exist in name. And we expect the filtered robots to equal the dummy filtered robots that we gave it. Let's save. And we see that something is failing because mock props 2 is not defined. We need to give it 3. And there you have it. We've now tested our main page, at least the main page method of filtered robots. And we also have some snapshot testing as well. So let's just look at our code coverage for now. Let's just run npm run test -- coverage. And again, this is always with testing. There's always many more things that you can do. We see that main page has a 100%, but there is a branch percentage. We're only testing 50% of the branch. And you see that the uncovered line is on 28. If we go back, we can go to main page and see that we have an is pending on line 28. How cool is that? The test says, all right, we're testing that the card list is rendering because we're always testing with is pending is true. As you can see here in our mock props, we always have is pending to false. So we might want to test is pending to true as well. And I'm going to leave that up to you to add. The important concept here is that there's so many ways to test. You can always use the coverage report as a reference, but try to be smart about your tests and make sure that you spend your time wisely because you're just going to have infinite things that you can do, but you only have limited time. That's it for now. I hope you have a better understanding of how container and components testing can be enhanced with enzyme and snapshot testing, and obviously the tools that come with Jest. The rest of the test is something I'm leaving up to you to complete for components and containers, but let's get to actions, constants, and reducers. We're going to want to test those as well. So in the next video, we're going to do just that. I'll see you in that one. Bye-bye. Welcome back. We have a good idea of how to test React components. But what about Redux and some of the reducers, actions, and constants that we have? Let's start off with reducers. And you're going to absolutely love this section. Because remember, our reducers are pure functions. And pure functions are a tester's dream. They're the easiest to test. So let's do that. I'm going to create a new file, call it reducers.test.js. And then in here, I'm going to import, well, we need the constants. So I'm going to import the constants and obviously our reducer. So import, we'll do import star as a new syntax as reducers from reducers. With this syntax, we can just do reducers dot whatever reducer that we've exported. So in our case, reducers dot search robots, reducers dot request robots, which reads nicely. All right, let's group these reducers this time around by using a describe block. So let's do describe search robots. We're going to do our first reducer here. And within here, oops, that's not what I wanted to do. Within here, we're going to have a test. The first test that says should return the initial state. Now, the initial state in the search robots reducer can be tested like this. So we can do expect reducers dot search robots. So that's our reducer. And remember, our reducer takes two things, a state and an action. And because if state doesn't exist or is undefined, we give it the initial state search. Let's do that. I'm going to say that the reducer.searchRobots gets undefined, so no state at the beginning, and it's going to get no action, but let's just give it an empty action for now. We want to test for those cases where, well, we have an undefined state. What happens? Well, we want it to equal our ideal state. And our ideal state in this case is to have search field to be an empty string. So let me save that. Open up our testing suite. And all right, everything is passing. If I press A, see that, yep, everything is logged out nicely, including our reducers.test. If we put in A in the search field, it's going to fail. All right, so that's great. That was super, super easy. What else can we do? Well, we expected that this reducer, when we see our change search field event, that it returns a new state. So once again, we can say that it should handle the change search field event. And we can say reducers.searchRobots, let's make this a little bit smaller, is going to get the state of, let's say, an empty state. Or, you know what? Let's add a const initial state search here and say that this initial state search is search field equals to this. All right, so we can just use initial search. So this is going to be the initial state, which equals to the empty string. And it's going to receive an action. And what kind of action is it going to receive? I'm going to remove this for now. Well, if you remember, our actions are going to have a type. And in this case, we'll say that type is going to be change search field that comes from our constants file. And we can make up the payload that it's going to send. So let's just say for now that the payload is going to be ABC. Now, what do we expect from that output? We expect that once it goes through this reducer, that the search field is going to equal ABC. So we can say search field should be ABC. Again, we have our initial state search, which is an empty string. It goes through this reducer with this action, and we now need the state, because remember, this reducer is just going to return the state. We want the state to be ABC. Let's save. And we have a bit of a fail here. Let's see what kind of an error we get. And it looks like just the unexpected token. Oh, and we need an extra bracket here. And we get an error saying that type is not defined because well, we don't need the type here. That's just a typo on my part. All right, so that's passing. How simple is that? With reducers, all we need to do is just give it some sort of an input and expect an output. And you can just keep going like this forever. Make your tests better and better. Let's do the next reducer now. Let's say that we want to, and let's make more space here. We want to describe the request robots reducer. In that case, we can just say that we have, well, let's create an initial state. So I'm going to, again, say const initial state for the robots. And if you remember, we have this as the initial state. So I'm just going to actually copy this. So this is our initial state for the test. And we want to do the same thing as above. It should return the initial state. So let's just copy and paste the above and just change the search robots to request robots. And we want that to equal the initial state. Let's save. And we have a failed test. Let's see what we failed here. Initial state robots is not defined because I need to add a const in here. Let's save. All right, everything is passing. We're getting our initial state as expected. That's good, but let's do another test and say that we want the 3 cases over here to be tested. So let's do an initial it should handle requests robots. Let's do pending first, action, and it's going to have something similar to here. So again, we're going to use the expect statement. It's going to have the reducers dot, this time request robots. It's going to receive the initial state of the robots. And then we'll give it an action of type request robots pending and a payload of, let's give it is pending to true. So we expect that when this happens, actually, if we take a look at the reducer, we see that it automatically sends the is pending to true, and there's no payload. So we don't need to set that. We don't need to send a payload, but we expect that payload to change from is pending. Well, let's do false here, because is pending when we start off is always false. And in here, we want this to equal the state of robots with an empty array is pending set to true. So let's save. All right, everything is passing, but I just noticed here that we don't actually want the default is pending to be true. We want it to be false, because when we first have the initial state, well, we haven't sent the promise yet. We haven't requested anything from the API. If we go into our reducers file, we see that we have the initial state here by true by mistake. We can just change that to false. Let's save. And in here, let's save here. Perfect. Everything is working, and the request robots pending is changing our is pending state to true. All right. Let's keep going. We have the second case, which is the success. So I'm just going to copy and paste here, and this time say request robots pending success. And this success should have, well, what should it have? Well, we need some sort of payload, because again, in our reducers, we have the robots action payload that we return or add to the state upon success. So let's just create that. In our type, we're going to say payload, and I'm going to return, let's just grab, let's just create a dummy ID of 123. Let's say name of test, and then finally email of test@gmail.com. You see over here that this is a string instead of a number. I believe in our component we're actually not distinguishing between a number and a string, so that's something we might want to fix in the future. But for now, we expect that if the payload is that, the state now gets updated with that payload. So let's copy that. And we also expect the isPending to be false. Again, if we remember our reducer, we're also changing our isPending to false on success. So let's save. And we have a bit of an error here. That is a simple arch nemesis comma. If we save, there it is, it passes. One final test. You can see it can get pretty repetitive with tests, but this is a good thing. With reducers, they're so simple to test that you just copy and paste a lot of the code, which again is fine for testing because this code was never going to go into production. So let's do the fail case here. That is the failed. And in this case, we want the payload. If we go back to our function, we want the payload to just have an error. So again, back here, we can just say, no, super upset that we got an error. And we expect the state to now have an error that is of no, and a isPending of false. Although I see here that we're actually not turning the isPending to false, which we should be. So if we save, add a comma, but we also expect the robots array to be returned, remember? So the robots array should be empty. And now we have this passing. Very cool. All right, that's enough for reducers. You see how simple they are to test. Simply checking the input against the output. And that's why you want to have these reducers everywhere and why Redux is so amazing. It's super easy to test. And if you think about it, all our logic is in our reducers. So if we have really, really good tests for our reducers, we cover a lot of the logic of our applications because reducers are the thing that take in actions and spit out the state. They're pretty much the controller or the brain of our app. Redux allows us to have really, really nice tests and keeping things simple on the React side by just doing snapshot testing or simple enzyme tests and testing out pure functions, which again is very useful. But for now, that's it for me. I'll see you in the next one. Bye-bye. Welcome back. We've written quite a few tests now, and well, 13 tests, that's not bad for a small app. There's definitely more that we can do. But I want to cover the last part now that I think is important, and that is testing our actions. Now, you might be asking yourself, what about constants? Are we not testing the constants file? But you can see here that constants are just simply, well, just assigning string constants to a variable. And when you're testing, you really want to decide for yourself what you need to test and what you don't. With testing, you can really get into a rabbit hole. That is, you just keep working on tests, and next thing you know, you haven't really done anything on the production side of things. And tests are important, but you really want to avoid the idea that, oh, I just need to have 100 pass tests or 100 snapshots, or I need my code coverage to be 100%. It's actually not a good idea to have 100% code coverage because it means that you're running tests that most likely don't need to be run, and your time could have been spent wisely in other areas of your app. Remember, there's infinite things that we can do to refactor, make our code prettier, write more tests, but we have limited time. So as a senior developer, you have to decide for yourself where the trade-offs are. All right, so constants file, we don't really need tests for that. But actions, I think we do need some tests for our actions. Let's create an action or actions.test file. And within here, let's once again import star as actions from our actions file. And with the first action that we have, which is the set search field, that's a pretty simple one. We just want to make sure that this function returns this object. So we can just use basic just functionality here. We can just have the it. And I know I should be using the describe to separate out the two actions that we have, but I think you get the idea. You can do that on your own. I don't want to get you too bored here. Let's have it should create an action to search robots. And this is going to have a simple, very simple text. Let's have a const.text that's going to equal our search term, woo. And the const, let's have the expected action. And the expected action is going to be our object of type. And let's import our constants here as well, so we can use them. It's going to have a type of change search field and a payload. And this is the expected action. So we expect that the action is going to include the woo text, or we don't need the string characters here. There you go. So we can simply just say expect actions dot search. What was it? It was set search field. Let's copy that. Set search field to have the text and to have to equal. So we want to set the search field with that text, and we need it to have the expected output of the action. So expected action. Let's save. And what did I miss here? Let's see. Nope, no comma here. Now I'm overusing the commas. This test section has been hard on me with the commas. All right, so there you go. We have a new test now in the actions that is passing. Very, very nice. And that's simple. We should know how to do that. But here's the challenging part now. We have this action, request robots, that, oh boy, does a dispatch, and I have an API call here. And this is something that you might not have seen. I've created an API folder here that simply extracts out our fetch call. So we give it a URL and does the response.json, so that it simplifies things for us, so we don't have to constantly do fetch.then response.json. But you've seen this before. Where is it? The actions just have the dispatch of request robots pending, and then finally it's going to have either success or failed. So how do we do this? Because looking at this action, we need dispatch, because this is an asynchronous action. And remember, we need Thunk for it. We need a Thunk middleware. Let's start writing the test and see what we can improve on. I'm going to close some of these tabs just to clean things out. There you go. And we're going to create a new if block. And in this if block, we want to say handles changing, or handles requesting robots API. And we'll say here that, well, the very first thing we want to do, we need to pass the dispatch to our function. Again, remember the dispatch here. Well, if we do it without this, so let's just test it out. If I run the expect actions.request robots action, I believe that's what it's called, yeah, request robots, and we leave it at this, and let's just say that we expect the type of the action to have the, let's say, request robots pending, and payload, if we look at our actions, we're not sending any payloads. So we can just go ahead and leave that as it is. If I save, we get one failed. Oh, request robots. And there you go. I get an error. Type error dispatch is not a function. Because remember, with asynchronous code, we need to pass this dispatch function to actually run this. And we used Thunk middleware in order for us to do this. If you remember index.js, we have the Thunk middleware in here. How do we do this? Well, there's a special package that we can use here. Let me exit out of this. Make this a little bit bigger. Let's clear. We can install a package called the Redux mock store. And remember that this gives us access to a fake store that we can use for testing. So let's do npm install -- save dev. And now we have access to this fake store. And the way we can use it is if I go up here and I say import configure store. And once again, this is all in their documentation for the package. We want to use the Redux mock store. And we also want to import the Thunk middleware from the Redux-Thunk package, which, if you remember, we already have in our index.js file. And the last thing we need to do, let me make sure it's lined up properly, is to configure and create this store. So we can simply just say const mock store equals configure mock store, and we configure it by giving it some properties, of which one of them is the middleware that we're going to use, which is going to be the Thunk middleware. So sometimes you're most likely going to add this in a setup test file. For now, I'm going to keep it in here because we only have one actions file, but you can usually export it so this store is available to all your tests. So now we can create the store equals to the mock store, and we run it. And I can now say store.dispatch. And store.dispatch takes actions.request robots. So we're going to dispatch this action. Remember, that's this action over here. And once we dispatch that, we can do something like const action equals to store.get actions. And now this action is going to contain what we need. Let me just console log it to show you. So console.log action. It's going to contain the action. Let's save and run npm test. Scroll up, and I have a bit of a console log area here, the configure mock store should be configure mock store here. All right, so we see that dispatch is not a function. Now, why is that? And this is something that you may have noticed while we're looking at the action.js file. You remember that Redux-Thunk expects a function to be returned. And although our program works the way it is now, you ideally want to, let's go back to the app.js. You see here that, and this is something we talked about before in the Redux section, you see here that we're just giving the dispatch to our request robots. But the way Thunk works is we want to make sure that we dispatch like this. Run the function inside of it so that we can run the dispatch function just like we have in our tests over here in the actions request robots, and we want to dispatch that. Otherwise, we would have to do store.dispatch in here, which is kind of ugly. Once again, to fix that, all we need to do is in the actions, because if you remember app.js, we have dispatch now, and request robots needs to run. So we're just going to have a function inside of a function. And we want to make sure that this works as well. So I'm going to go back and do npm start. All right, and everything still works. But now we're able to hopefully run the tests better. So npm test. Go back to our tests, and we see that we have one failed file. We have a type request robots pending that we expected, but we got a function instead. And if we log actions, we see that we have a action type of request robots pending, which we're getting. And that's because you can see that the action is returning an array, and we want the object of the action. In the expect, because we no longer need to run this action, it's all being run up here and we can get the actions, we can just say expect action, the first item in the array, to be run. And look at that, everything works. And I know this can get a little bit confusing. And anytime you're testing asynchronous things, it can get pretty difficult. But all we did was really create a fake store that had the Thunk middleware, so it waits for any functions that are returned from an action, in which case we did with our actions.requestRobots, because you see here that it returns an action that takes the dispatch. And now this dispatch gets automatically sent into request robots. It's going to receive the actions. And because if we go to our action.js, the very first thing we dispatch is the pending action, we receive action 0 to equal the expected action of robots pending. All right, so how do we test the request robot success and request robots failed? And that's a little challenge that I'm going to leave for you to decide what to do based on what we've learned about asynchronous tests and also what we've learned about mocking our Redux store. And this is a tough, challenging problem. So use whatever resources you have at hand, internet, Google, Stack Overflow, anything you can to try and figure this out. Because that's what testing's all about. Testing is sometimes very simple when you have pure functional components or functions, or it could be really difficult when you have all these dependencies that your tests run on. But every situation is different, and luckily for us, with all these resources online, you can figure it out as long as you understand how things work and what the errors mean, which as a senior developer is the most important thing. They don't know every single syntax in a library and know all the documentation. They just understand how things work underneath the hood so that when the problem arises, they can solve it. Finally, I wanted to show you two things that may help you or I think are great whenever you're doing asynchronous tests. The first one is a library called Nock. And Nock simply is an npm package that you can install. And you can see over here that we can pretend that we're doing a URL call. We can do a GET request to an endpoint, and we can automatically reply with whatever we want. We can say that this reply had a status of 200, and it gave us username and an email. And this sets you up really nicely for asynchronous tests. Once you get deep into testing as well, especially when you start working with APIs, Supertest is one of my favorite tools. Simply by importing Supertest, just like here, and we have the request, you can request, let's say, an Express app, and you can do all these things like running GET and expecting a content type and a status and a ton of things. Now, this is beyond the scope of this course, and it's something that you can take a look at as you get more and more into testing. But just realize that there's tons of tools out there for you to use to write clean, nice, beautiful tests. I'll see you in the next one. Bye-bye. Hey, it's Bruno here. This is fantastic. I can't believe how many tests you wrote, and oh man, I'm looking forward to not having as many bugs in our app. Really thankful for your work, and I hope you understand that I really value your contribution to our team. Keiko Corp thanks you. All right, we finished a pretty tough section. I think testing is one of those things that can really stump people and can really frustrate you as well. But we're no longer junior developers here when it comes to testing. We understand their purposes and their limitations. We learned that there are three main types of tests, which are unit tests, integration tests, automation tests. And that out of all these three, unit tests are the easiest to write and also the cheapest for companies to use as a tool for us to minimize bugs. And you usually want to run unit tests with integration tests completely separate in a separate process from something like automation tests. A topic that can get pretty complicated, but luckily for us, there's a ton of libraries that we can use. We also learned all the tools that are available in the ecosystem for us to test. At the end of the day, though, they're all very similar and they all try to accomplish the same thing. Simply test our code, assert some statements, run these tests, maybe spy on some functions, and then see the output, make sure they're passed, and make sure that we have a good code coverage. But we also learned that having a perfect code coverage isn't necessarily what you want to do. You never want to just strive for 100% code coverage because at the end of the day, those are just numbers. Everything depends on your application and what your goals are. So be careful with code coverage. It's really easy to get stuck in a hole where you're just writing tests that aren't good, but you're just trying to get that 100%. Focus on the quality of the test versus the quantity. We learned how tests can be run in different environments. And we also learned that React has enzyme and snapshot testing to really help us out with component rendering. They all made writing tests a lot simpler. Finally, we have a better idea of the testing environment. Tests are simply a way for us to use in development to make sure that our code as it grows is maintainable and produces less bugs as more people join the team and more people touch the code and code lines increase. Using all the tools that we have at our disposal, we're able to be smart about the tests that we write. We're focusing on what is important to test. What are the key features of our apps that we want to make sure we test properly? And we want to make sure that these tests are not complicated. They're very nice and readable, so if anybody comes onto the team, they understand what the tests do. Remember, if a test becomes complicated, perhaps there's something in your actual code that could be fixed. Don't think of tests as something that you do after you finish all your code. Some people actually enjoy doing them before you write your real code, so that it gives you ideas of how to structure your code in a nice, clean fashion. So think about this. Make tests that are of good quality, not just quantity, and write your code so that they're in nice, simple, testable units. Good job getting this far. I'll see you in the next section. Bye-bye.
Welcome back, everyone. I know some of you have been curious about all these things about Webpack and Babel that we occasionally mention throughout this course. If you remember from one of the initial lessons that we taught, the big thing about Create React App is that it hides away all of the Babel and all of the Webpack configurations that you would normally have to figure out. It's one of the big advantages of Create React App because Webpack and Babel have a lot of possible configurations that you have to do. However, if you just wanted to get started with a React application, having to learn those two new technologies is a big overhead. But now that we've gotten really good at React and using Create React App, I think it's about time that I show you Webpack and Babel. I'm going to show you how we can actually set up our React application to run Webpack and Babel in a very easy and efficient way. I'm going to show you with as little code as possible so that you can understand what is happening with Webpack as well as Babel. Both are actually quite simple, and with the newest versions, they've really reduced the amount of configuration that you have to do for either. So in this lesson, we're really going to look at the bare bones of what we need to set up so we truly and deeply understand the concepts. So with Webpack, what you can do is actually go to this link I'm going to provide you inside of your resources, and it's going to take you to this repo. This repo I have is just the most fundamental bare bones React implementation before any Webpack has been included. So simply fork this project so that you get a copy of it. And then once it's finished forking, simply clone it down. So you're going to click your own and you're going to click clone, and make sure to use HTTPS if you are not set up your SSH. If you have set up SSH, then you can clone with SSH. Otherwise, use HTTPS. So just copy this key. And what we're going to do is go to our terminal and we are just going to clone it down. Now, I'm going to call mine Webpack project because, of course, I made this project, so I have the same name already. But let's just clone down whatever name you want. I'm going to call my Webpack project and cd into it. Now, let's take a look at what we have currently. And what we're going to look at is just inside of our source folder. So far, it's a very simple application. It has an app.jsx, and all we import inside app.jsx is React, our style sheet, and then all we have defined is this app div with a card div, and inside is an h1 that says our React is working. The most simple app component that you can imagine. So what I do is export this out by default and bring it into index.js. So as you're used to by now, this index.js file is where we're going to enter from our application. So in here, I also import React and React DOM. I import our app component that I just made, and then I render the app and I replace the element with the ID of root. We can find that inside of this index.html file, that in the body, there's just this simple div with an ID of root. This is as simple of a setup as possible. But we have a React component, we have some styles, and we want to output a optimized build with all of this converted into a version of JavaScript that our browser can understand. So we understand all this about React already. We know about Webpack, we know about Babel, What they do mostly is that Babel allows us to convert files into other files that our browser can understand. That's Webpack's purpose. So this JSX code we've written, this JS code, even the HTML and the CSS, all of this is currently in a format where we're importing it in a style that older browsers can't understand. This import style comes with ES6, and ES6 doesn't work for some browsers because they only support ES5. So this is what Webpack's main goal is that Webpack wants to help us convert all of this code into versions that browsers can understand. So let's actually explore this. In order for us to use Webpack, we have to bring it into our application. So I'm using Yarn. You can use NPM if you prefer NPM. One thing to note with NPM is that every time we install a project, you have to make sure that whatever we install at the end, you append --save-dev. Because these are developer dependencies and not regular dependencies. With Yarn, you don't have to do this. This is just a thing to keep note. To get started, we need to add 2 packages. The first is Webpack. The second is Webpack CLI. So it's got to be yarn add. So these 2 packages allow us to begin using Webpack inside of our application. In order to use Webpack, there's 2 things that we got to add to our actual application. The first is a file inside of our root folder called webpack.config.js. When we run Webpack, Webpack will automatically know to look for this file. And in order for us to actually run Webpack, we have to add a new script inside of our scripts object here in our package.json. So what we'll add is this build script. And this build script is just going to run webpack --mode production. So this is saying that I want to run Webpack, use the configuration.js file, and then I want to spit out a production build. So this is similar to pretty much what we see Create React App does when we run our build script in our project before. It was just hiding all of this away for us. The thing is that inside of our Webpack config, what we're going to do is we have to remember that here we don't have ES6 syntax. We have to use the old ES5 syntax. So in order for us to export out anything, we have to say module.exports equals this object, because what we're trying to export out of this file is this object of configuration options. We're going to say module, and we're going to define this thing called rules. So inside of Webpack, it's got many modules that you can run. The first one is rules. Rules is a way to define Webpack what it needs to do based on certain file types that it encounters. Now, what do I mean by this? Well, as we know, we are writing JSX code or ES6JS code. Webpack doesn't need to convert CSS code over into JS code, because with CSS code, if it's using Sass or if we're using some other version of a CSS library that does not come by default with most browsers, we need a different set of rules than our JavaScript rules, because we need a different set of loaders than JavaScript loaders. And this actually brings us to the concept of loaders. But we'll talk about it once we start writing out this rules object. So what we're going to say is we are going to say that this test string is what we want to match against. So what type of file extensions we want to match against. Now here you're going to actually have to write a little bit of regex. And it's actually not so hard. I'm going to give you a regex builder, but we're going to say that inside of these slash marks that we want to look up any files that end with the dot, and then we're going to say JS or JSX. And then you add the $ to empty or to end the actual test. So this is just saying, I want you to find me any files with the extension .js or .jsx. That's all it is. After this, we want to exclude our node modules because we don't want to run or build any of our node module code. The packages that we download are already optimized. They don't need to run through any of these loaders. They're already converted ahead of time, or they should be. At least a good library is. And then what we're going to say is this use property. So the use property tells Webpack what loader it needs to run. And the loader is going to be the helper that actually converts this code into the actual version. So you can kind of see Webpack as the coordinator and the loaders as the actual packages that transpile this code down into the version that we want it to be. And here is where we're going to use Babel, because Babel is the library that helps transpile JavaScript and JSX down into older versions of JavaScript. So we're going to include in a couple other libraries related to Babel. So we'll go back to our terminal, and what we're going to do is we are going to say yarn add at Babel core. So we want the core Babel library. We want at Babel / preset env. And this library, the preset env, comes with transpiling ES6 down to ES5. That's all that library does. We also want Babel / preset react. Now, of course, Babel can convert everything. It can convert Vue, it can convert Angular, it can convert Aurora, it can convert all kinds of different JavaScript libraries down. You just have to pick the specific ones you want. That's why it's all at Babel / and then the name of the smaller library we want to include. We also need to include the Babel loader. So these ones were for our actual Babel configuration. The Babel loader is just so that we have the Babel loader for Webpack. And once we have this, we can go back to our application. And now what we're going to add in is inside of here, we're going to say the loader, we want to use the Babel loader. Now, what Babel loader knows to do is look inside of our root directory for a file called Babel RC. So the Babel RC file is going to be the file that tells Babel what it needs to transpile down to. And here we're just simply going to create an object where the presets is the property that points to an array. And inside of this array, we're going to include those two presets we included. The first one was preset env, which, as I explained, converts ES6 down to ES5. And we're also going to include Babel preset react. So this compiles React down into ES5, or another version of JavaScript and HTML that our browser understands. So if you've ever been curious, why is it that you can put .js or .jsx and our code always works? Well, under the hood, this is what's happening. Create React App is doing the exact same thing. It's just taking all of our .js and .jsx files and running it through the Babel loader anyways. That's why, even though you're writing JSX code and appending your files.js, your code still works. This is the loader that's doing that for you. So hopefully with this, we now understand what it is that Babel did. Babel's very simple. It is a loader inside of Webpack that converts JavaScript files into older JavaScript files. It uses certain types of presets that you pass to it. And of course, there's other configuration options you can add if you want to be more explicit. You can find those in the documentation that I'm going to link in the resources. But this is the base that we need in order to convert our application down. So with this, hopefully we at least understand what Babel does with JavaScript. Now, we can't test this until the very end once we set up some other things, which we'll do in the next lesson. But conceptually, this is all Webpack and Babel do. So let's move on with the next lesson. So in the last lesson, we added in our Babel loader so that we can convert our JS and JSX files down into ES5 JS files that our browser can understand. What we're going to do now is we need to actually bring in another loader because we need to actually tell Webpack what it should do with CSS. It actually doesn't know how to render and bring in CSS yet. This is a thing that we have to do with Webpack. What we're going to bring in is two new loaders. One loader is called the style loader, and the other loader is CSS loader. Now, style loader is what allows it to convert different types of style files. The style loader actually allows us to import in style files into our React component files. The actual CSS loader is what converts CSS into a version, or not even a version, but it's just what allows the CSS to be read by our JavaScript files. We can use a Sass loader if we wanted to convert Sass over as well, but you always need CSS loader and style loader. So we're just going to bring those in. Style loader as well as CSS loader. Now that we have those two loaders in, we're going to define a new rule. And here we want to say that for any file that ends in CSS. So just like our JS, it's following the very same conventional pattern. Except we don't need these brackets because we need the brackets when we want to do the or, but we don't here in this context. We want to say for any CSS files, we want to just run them through the two loaders. And use can take an object with multiple options, or it can take an array. And here we're going to pass an array because we want it to run through two loaders. Keep in mind here that the order does matter. Loaders evaluate from right to left, and we want to render the CSS loader first before we do the style loader. So because we're going right to left and we want style loader to be last, we're going to say style loader first and then CSS loader second. And that's all we need for CSS. The last thing that we need to do is we need to make sure that we can output and build a HTML file that we can actually finally read in our final production build. In order to do that, we need two more tools. So going back to our terminal, we are going to add in HTML loader, which as you're familiar with now, it's simply just a loader, but we also need HTML Webpack plugin. So the HTML loader is the thing that lets us read our HTML file inside of our React application. But the Webpack plugin is what allows us to actually place the output somewhere. So what it's going to do is it's going to build all of our HTML files and it's going to create efficient chunks as we saw in our performance optimization courses, where they're the HTML bundles with the JavaScript for each page. And this plugin actually helps us do that. So here we're just going to add these two libraries. And once we have that, let's go back to our rules and let's add another one. So here what we want to do is we want to say, in order to use our HTML plugin loader, it's pretty much going to be the exact same as what we saw with the style loader and the JS loader. We need a test. And just as we saw, we're going to write that we're matching anything that ends in .html. And then we're just going to use the loader, HTML loader. So as simple as that. The only thing now is that after rules, we have to actually bring in that HTML plugin that we were talking about. So there's another property called plugins. And inside of plugins, we're going to call new, and then we got to call the actual plugin. So we got to bring that plugin into our Webpack config file. So we're going to say const HTML Webpack plugin is equal to require HTML Webpack plugin. So we're bringing it in here. We want to instantiate an instance of it, and we're going to pass to it a configuration object. This object is simply going to take the template of the actual file that it's going to use as the index.html starting point in our React application. So we wanted to take this one that we have in our source because this is the one that renders the div ID of root. Using the app.js code and all of the index.js code that we have here, what's going to happen is that inside of Babel Loader always by default tries to go for a index.js file inside of your source folder. That's why we always define index.js inside of source. So it's going to find this file, it's going to run this code, and it's going to use that index.html file that we supply to the actual HTML plugin as the file that it needs to run the JavaScript on, which is where we're going to end up using our React DOM.render in order to replace that div with the ID of root with our app component. So it's actually the combination of those two loaders together inside of our Webpack that ends up producing and providing outside the new JavaScript and HTML files that we need for our final build. So finally, with this template, we're just going to pass it the string to our index.html. And this is our Webpack config. A lot of new concepts, but honestly, if you think about what it is that we wrote, it's actually quite simple. We're just following along with some simple rules and using loaders. It's just all configuration with Webpack. That's really all it is. Of course, I'm going to link all of the documentation for this so that you can see what other options you have, understand a little better what else you can do with these different options. But this is just a bare bones setup so that we can run our Webpack and render our React code. Now that we have all this, let's just run build because we've got our config set up. We've got Webpack. Well, it looks like we have a little error here. Oh, I put this in the wrong place. This should be one lower. So plugins comes after module. And now let's try this again. So it's going to run the Webpack build. Can't find app inside of app. This is a syntax issue. So inside of index.js, this should be app.jsx. Because our loader is looking specifically for this, it does not default. So that's actually one of the things with Webpack. Let's fix that. Let's try this again. So my autocomplete will automatically try and correct sometimes without doing the .jsx, as you've seen throughout this course as I've imported multiple files together. So this is just one of the caveats and nuances with Webpack. If you want that feature, you actually have to write it yourself as a config option. But now we finished our build. But let's actually go over what just happened. We ran into a couple of minor errors. This is very normal with configuration of Webpack. This is why the Create React team and actually many CLI tools, even for Angular and Vue, try and hide this away from developers. Because it's so error prone. There's so many little nuances you can miss with Webpack that it's really frustrating to work with in that sense. That's not to say that it's not worth learning. It definitely is worth learning at least what's happening. But the tools, as Andre mentioned in an earlier lesson, an entire team is dedicated to helping you build and set up your configuration with Webpack and Babel to the most optimized degree possible. It's worth knowing what's happening under the hood, at least like demystifying what Webpack and Babel do. But writing it from scratch could bring you a lot of headache. And the configuration options are pretty much just things you have to do by memory and looking at the actual configuration. There's no real logic beyond what it is that each configuration tool is trying to do for you. But now that we have our final build, we see that it succeeded. Inside, we now see we have this new dist folder and an HTML. So let's actually open this. Not in the terminal, but let's open up our index.html. Let's reveal in Finder, and let's just open it up in our browser. And there we see our component rendered, our React is working, so we know that our loader is working, and we know that our Webpack is all working. And that's pretty much it. This is all Webpack and Babel do. It transpiles it down, it builds it into a final index.html as well as main.js bundle that we download as we saw in our performance section. So this is actually what's helping. Webpack is helping improve our performance by bundling these files for us when we make these requests. That's why we included the HTML bundle. This is the main advantage of Webpack. Webpack allows us to increase our performance because it sets up a lot of these things for us. The React team by default assumes and must use Webpack. All of these new technologies and frameworks all leverage Webpack under the hood to help them optimize their performance and build the code that you write in Angular or in React down into a readable version for browsers. But now that we finally have our Webpack and our configuration options, we understand what it is that Webpack does. Dig around with the documentation, play with it a little bit yourself if you want to, for example, include the Sass loader. I can include a link to the Sass loader. Just try and follow the instructions and see if you can fit it in. Write a Sass file and see what happens. So hopefully with that, you understand at least conceptually what Webpack and Babel do. That's not to say that for your projects, especially when you're on a new team, that you suddenly write this yourself from scratch. If you also want, you can create a new Create React app application, eject it, and look at how complicated that code is. Because now you at least have a better understanding of what it is that Webpack is doing. Look at the Babel RC as well and see how many configuration options there are. Compare and contrast that with the documentation, and you'll at least see all of the available possibilities that you have in front of you with Webpack and Babel. So hopefully you've enjoyed this lesson, and I'll see you in the next lesson. Hello everyone, and welcome to this lesson on building a blog website with Gatsby. My name is Yihua, and I'm one of the instructors alongside Andre that teaches the React course from zero to mastery. Now, in this lesson, I am going to talk about Gatsby and how we can leverage Gatsby in order to build a blog website. Now, before we continue, I do want to note that this lesson assumes that you know the basics of React and GraphQL. We also make the assumption that you understand some of the caveats behind some of the libraries in the React ecosystem, such as React Router. If you are unfamiliar with this, we do teach this in the course, Otherwise, you may have to become more familiar with these concepts before proceeding with this lesson. You can definitely watch this lesson still, but you might not be able to understand all of the code that we'll end up writing inside of this section. Now, if that is not a problem for you, then let's take a deep dive into what Gatsby is in the first place. So as I mentioned, Gatsby is a framework that is written in React. It's a framework that has already combined together some of the best React ecosystem libraries into one bundle and has an opinionated way about how you should use it in order to build a static website. In order for us to actually understand when we should use something like Gatsby, we have to understand some of the competing technologies that you've definitely at least used or heard about. So let's take a look at this image. Let us go over one high-level concept in React. So we know that React is a front-end based UI rendering library. We write React code, which is a combination of JavaScript and JSX, in order for us to compile that code that we've written in React down into JS, CSS, and HTML using a loader like Webpack as well as a transpiler like Babel. Now, those files are the files that any web page that our browser loads consumes in order to build such a web page. So when we build our websites in React, we might be writing React code, but there is some compile step along the way that builds them into JavaScript, CSS, and HTML files that our browser is able to consume. Now, keeping this in mind, let's take a breakdown of 3 technologies that we see in the React ecosystem that try and solve the problem of how you develop React applications. Now, those are Gatsby, Create React App, and Next.js. Now, you've definitely heard of Create React App and you've definitely used it if you've taken this course. Create React App is a very quick way for you to start up a React application, and it leverages what is called client-side rendering. Now, what client-side rendering means is that it leverages the browser in order to build out the HTML that gets served whenever a user navigates to any page on your React application. So if you were to see this browser here, when the user navigates to the home route and then loads up the home component, what happens is that the React code that we've written is built and passed to that user's browser engine. Now, that engine will end up being the one that actually generates the HTML required for that homepage and then loads it up onto the browser. The same thing happens whenever they navigate to any other route, such as collections. But the main idea here is that the browser engine is the thing that is generating the HTML pages that the browser needs to load related to our React application. Everything is rendered on the client side, so on the browser. Now, Create React App is a great tool when you want to build a really dynamic website in React, but you don't have a lot of static images that come by default with the actual application, or a lot of really deeply nested and really complex logic that ends up building your pages. Now, when you do have a website that is performing slowly and can exceed the amount of power that our browser engine has, then you want to use something like Next.js. Now, if you've never heard of Next.js, it is a framework that allows you to write React and leverage server-side rendering. Server-side rendering is almost the exact same conceptually as client-side rendering, except instead of letting the client or the browser's engine be the actual thing that ends up compiling and generating the HTML code for our browser routes whenever our users navigate to any of our pages, we let the backend server build and generate the HTML files that the user needs in order to view the home route, the collections route, or any route for that matter. So whenever the user navigates to another route, for example, like our home, then this will communicate to our backend server that they need the HTML related to home. So the server will start to generate using our React code the actual HTML required. And this is way more robust because our backend server is more powerful and it's capable of generating it really quickly compared to our browser. So you want to use Next.js when you need to build a really robust and large website that might end up having really complex logic to build out your views. Now, the main thing here to remember though is that Next.js and Create React App are both dynamically generated, meaning that we directly generate the HTML whenever the browser navigates to different routes. So this is all live generated. Whereas something like Gatsby is what's called a static generated website. So what this means is that all of the code that builds to the HTML pages that end up comprising our application is all done at the build step. So similar to when we run build with Create React App, when we push our Gatsby code up to a server or up to a hosting platform of some kind, they will run the build script, which will automatically generate all of the static HTML that our browsers end up using in order to display the views, which means that none of this code is generated dynamically. It's all generated way ahead of time when you push your code up onto your server. So this is the main difference with Gatsby. So it's really good when you want to build static websites that generally don't need to dynamically change the views that often. By doing so, this is actually exactly what we need for a blog website where much of the actual content is already predetermined. It's already written. So all we want to do is just display a bunch of blog posts and navigate between them. And Gatsby is the perfect solution for that. So in the next lesson, I'm going to teach you how we can get started with Gatsby. So I'll see you in the next lesson. Hello and welcome back. So in the last lesson, we learned about what it is that Gatsby does at a high level. Now in this lesson, let's actually take a look at what we're going to build. So what you'll end up building is just this basic blog website in this lesson. There's not that much styling to it because what I'm trying to show you is just the base concepts in Gatsby in order to get you up and running. Now, how you end up actually styling your blog or adding features to your blog is entirely up to you and definitely part of the coding challenge. Now, the blog itself is very simple. It simply has a list of all of our blog posts that you can navigate to and navigate back from, but the main thing to keep in mind here is that a lot of this content is actually dynamically generated inside of Gatsby. I'll show you what I mean. It's actually really interesting because Gatsby's style of setting up this blog is different from how you would typically write it in a React application because of a lot of the plugins and APIs inside of Gatsby in how it generates this static website. Now, we're also going to learn how to host our blog on Netlify. So Netlify is a company that offers this amazing backend service for you to host static websites. And the free tier of Netlify is extremely generous. It's way more than what we need for our blog, and it's incredibly easy. It actually gives us continuous deployment pretty much right out the gate with GitHub. And what that means is that we're able to push our code to GitHub, connect it to Netlify, and whenever we push code to that GitHub repo, Netlify will automatically redeploy and rebuild our website and update our URL with our latest code. So that's a really, really great service that we can leverage while using Gatsby because we're building static websites. So now that we know what we're building and where we're going to host it to, let's actually take a look at how to write this code. So let's go to our terminal. And what we're going to leverage is the Gatsby CLI. So CLI is a command line interface, which is a tool that we can use to quickly set up and build Gatsby projects, pretty much just like Create React App. In order to use it, we're going to leverage NPX, which, as you remember, is a new feature that comes with a later version of NPM that allows us to leverage packages without having to download them globally on our computer. So using npx, I'm going to say Gatsby new and then Gatsby blog. So what this does is it will initialize and clone down using the Gatsby starter, a new Gatsby project for me. Now there's actually a lot of other starter projects you're able to leverage, and all you would do is after saying Gatsby blog or whatever name you want for your Gatsby project, you say space and then you link the new starter that you want to actually leverage. And Gatsby provides all these starters depending on what kind of website you're looking to build. In fact, there's even a Gatsby blog starter that Dan Abramov, the creator of Redux and a very, very prominent member of the React core team, uses to create his new blog over Reacted. Now, you can totally take a look at this afterwards, but let's just get started first to understand all of the nuances in using Gatsby. So once we've actually created our new Gatsby blog repo, let's cd into it. And let's just open up the code and see what we have. Now, you'll see right away that our folder structure comes with these different files here. Inside of the source folder, we have something that we might be used to seeing with our React projects, which is a components folder. We have an images folder that holds some images, and we have these pages folders. Now, we're going to talk about the pages folder, but first, let's just take a look at these 4 files we have here. The Gatsby browser.js, the Gatsby config.js, Gatsby node.js, and Gatsby SSR. So, you can actually get server-side rendering with Gatsby if you follow some of the instructions with the Gatsby SSR API doc. Now, we're not actually going to do that in this course, but it's nice to know that you can achieve it with Gatsby. But so if you're curious to see how to implement it after this course, you can definitely take a look at these docs. Gatsby node we're going to use in order to build out some of the more server required things that we will definitely explore in this course. So for now, just understand that this is where we end up writing some of our node related code. Now the Gatsby config is actually the main file that we're going to focus on inside of this lesson at the very least. The Gatsby config holds a lot of the configuration options that we need in order for Gatsby to know what to do. Now, this site metadata is actually data that we can pull into our components using GraphQL inside of our Gatsby project. So if we wanted access to a title, this description, or the author in any way, we are able to leverage GraphQL and pull this site metadata right out of this Gatsby config object. These plugins are additional little libraries in Gatsby that allow you to do different things with different files. So we'll definitely explore this later, but you can see these as kind of additional helper libraries that transform the way that we're able to use Gatsby. And we'll take a better look at this in a later lesson. For now, just understand that this plugins array is where we would add any new plugins that we want for our Gatsby project. Now, Gatsby does have a lot of configuration and a lot of plugins. So you can definitely take some time and read a lot of the documentation that's available for many of the plugins that come by default with the starter. There's also going to be a lot of Gatsby concepts that we're going to cover. And honestly, you kind of have to just follow through with this lesson in order to understand at the end how all of these pieces come together. Because there's so many moving parts in order for us to end up building our blog, but Gatsby does try and make it as easy as possible. So as we build out some of these features, we're going to go back to a lot of these files to better understand what they're for. Right now, I just want to introduce you to the base files so that we understand what we're doing. Now, one of the big things is actually to look at package.json. And looking at the scripts, we see that it does provide us with quite a few. Now, the main one that we want is actually Gatsby develop. because Gatsby develop is what we use in order to serve up our website on localhost. So let's actually just test that first. So what we'll do is just run npm run develop. And what this will do is it will build up our new Gatsby application, and it'll actually give us two routes. The first one will be localhost 8000. That is going to host the actual website. The second URL they're going to give us is localhost 8000 /___ GraphQL. And this is going to be a GraphQL playground. But we'll look at that in the next lesson. In this lesson, let's just navigate to localhost 8000 in order to see what it is that we get. So by default, we get this Gatsby default page, and we see that there's some routing that's set up for us. So we load this little astronaut, and if we click go to page, it takes us to a different page at this route, and we can go back to our home page. Really simple, really quick. They've just set up something here for us to just build off of. So now that we see this, in the next lesson, let's take a look at how the code actually translates to what we see here. So I'll see you in the next lesson. Hello and welcome back. So in the last lesson, we served up our localhost 8000, which is our Gatsby application. And in it, we saw that right away, we have these two pages. This first page has this little astronaut picture on it, and the second page is just a welcome to page 2, that we can navigate back to page 1. Now, this is really interesting because this actually allows us to highlight one of the key features in Gatsby, which is that inside of this pages folder, as long as you add a new file here, Gatsby will automatically try to load a new page for you, meaning that it will build a new page based on the title of the file that you write. And inside of this file, index.js, this is actually our astronaut page. And what it is just importing React, and it's a functional component that leverages this link. Now, this link component that we get from Gatsby is pretty much a Gatsby version of the React router link, meaning that navigation happens with this link component. We also import this layout, image, and SEO component. Now, these are just components that come by default with Gatsby, and they're actually quite simple. The layout component essentially wraps around some bunch of HTML elements or components, and it provides some styling to it, as well as it provides it some data that we'll look at a little later. The image component allows us to do lazy loading with images and optimizing those images. It's just a Gatsby methodology that makes images more performant on the web. And then the SEO component is meant exactly for search engine optimizations. You can pass it a title, a description, a lang, a meta, or any of these other properties that you see right here. So what this does is it makes search engine crawlers more performant for our website, so that we show up higher when people might be Googling for things related to what we write inside of our blog. Now, we will use some of these components when we actually build out our blog posts, but for now, let's go back to looking at our pages folder. So as I explained earlier, if you add a new file, Gatsby will generate a new route for you inside of your application based on the name of the file that you created. So let's actually just make a new file called page3.js. You can name this whatever you want, but I'm just going to call it page 3. I'm going to take this code from page 2 and just remove some things that we don't need. And what I'm going to do is simply just generate an h1, rename this to third page, and then say hello from the third page. Now, as long as we export something out that is a component as the default from this file, Gatsby will know to use this component for that route. So let's test this out. If we go back to our application and navigate to our new page 3, we'll see that we have our hello from the third page. So this is what's really great about Gatsby. It's really easy to build new routes and new pages just by adding files to our pages folder and making sure we export as the default some component that allows Gatsby to use that as the page that it's trying to render. Now, another great thing we actually get with our pages is access to this 404. Now, this 404 page, Gatsby will automatically know to use in live production if the user navigates to some page that doesn't exist. So inside of our development server, if we go to say something like this, we'll see that it takes us to a page that tells us actually all of the routes we have available to access. But in live production, it will end up showing this 404 page. And this is one of the nice things about using Gatsby. For a more opinionated framework like this, it has made a lot of these decisions for us in terms of how to handle routing, how to set up pages, because unlike a normal React application that just rolls with React, you have to include all of the different libraries that you want to include in order to handle routing, in order to handle 404s. As you'll see inside of our course, we have to make those decisions for ourselves. But with Gatsby, you just have to learn how Gatsby does certain things and then follow along with the way that Gatsby has set up the project. So for us in this case, it's just a matter of how do we handle the pages that we want to add to our application. So conceptually, we just have to keep this in mind. If we want to make new pages, we add them into this page folder, and the page route will be named whatever name we've given to our files. Now, this does bring me to a very important caveat about Gatsby. Because Gatsby builds all of our static pages ahead of time, we do not dynamically compose them, which means that the way that you're used to structuring your React code is going to be a little different. Now, one thing that you might have noticed is that every one of our pages is wrapped inside of our layout component. And the layout component we get with Gatsby with this starter project. Now, the reason for this is because we need to actually render the header and the footer and any consistent styling between the pages every single time. Now, why is it this way? Well, if you remember in the last lesson, we talked about Gatsby being a static site generator, meaning that Gatsby needs to actually build those pages on the build step, meaning that it generates every single page's complete HTML that the user needs on their browser in order to view the page. So if we want this header and footer on every single page that we have, including our route, including page 2, and including the new page 3 component that we built and any other further page, we need to always provide it with all of the components and all of the styling for that page on that page's code. This is different from a typical React application where you might have different levels of components that will house the routes that hold the subsequent nested components inside, as you might see when you build something in React using a library like React Router DOM. In React Router DOM, you might have a high-level app component that has route components inside that will then lead to further nested trees of components, meaning that you don't have to actually dynamically compose this code every single time in every single component if you want to render a header. Again, this is a caveat of statically generated websites because statically generated websites need to generate static HTML for every single page. So how you want that page to look needs to have everything on it already in order for it to generate that page. So hopefully that makes sense because that's a big caveat about building our pages inside of Gatsby. Now, with that in mind, one other thing about the layout is we'll see here that we are using a little bit of GraphQL. Now, you might be familiar with everything here, especially if you've taken the course, as we learned with GraphQL. The difference here is that Gatsby has provided its own hook called useStaticQuery. useStaticQuery is a custom hook that Gatsby wrote that allows you to extract the value of whatever query you're making against the GraphQL in order to pluck out the data. Now, as you can see here, what their query is querying is this thing called site with this object that calls for the metadata. Now, this metadata is what we saw inside of our Gatsby config. This site metadata contains a title, description, and author by default, which you can pull off using GraphQL and adding that query that we saw in the layout component. And by doing so, we're now able to pluck off that title that we've stored in our config and then render it inside of this layout component so that we don't have to fetch it inside of every single one of our page components. Now, for example, if we wanted to change the title, if we go to our config object and we change the title here to Yihua's blog, we'll actually see that we get that update. So that's one of the great things as well, is that if we wanted to keep something on our website that we needed to use consistently on all of our pages, probably through our layout of some kind, we can easily just change it inside of the site metadata. Now, we're definitely going to take a deeper look at the GraphQL section that comes with Gatsby, and we're going to do that in the next lesson. So I will see you in the next lesson. So with every Gatsby project, because Gatsby rolls with GraphQL by default as its query language, you're able to actually access a GraphQL playground by going to localhost 8000 __ GraphQL. This will load up this playground that shows us all of the queries we're able to make inside of GraphQL. Now, this is really good because we're actually able to do a lot of different things with this GraphQL query list. For example, by default, we're actually able to access every single file inside of our directory. Now, when I say this, what do I mean? So if you look inside of your Gatsby config, you'll see that there's this plugin here called Gatsby Source File System. Now, Gatsby Source File System is a way for you to actually access the nodes that represent the files inside of this directory. With the name and the path, the name just essentially allows us to tell Gatsby what it is that we want to put this under when we query for it. Now, what are we querying for is actually going to be any files that lives inside this path that we provided. So here we see that we're string interpolating this directory name, which pretty much just represents whatever the final directory structure is. And I want to go into our source folder and then our images folder. So right here. Now it's named images because what it's trying to do is get all of the image files. Now, if we go back to our GraphQL, we'll see that what it is that we got is actually this thing called all file. Now, inside of this Explorer, you'll see this list of all the different queries that we can access. So if we wanted to actually see what that plugin was giving us, if I do all file and I hit Command Enter or Control Enter if you're on a Windows, you'll see that it automatically populates with these properties of edges, node, and then the ID. Now, edges represent the actual path to that file that we're pointing to. So meaning that edges will be the array of the number of files that we have inside of our images folder. Now, inside of every edge will be a node, and that node is the representation of what that file is. Now, the node Gatsby will convert for us. But what that means is that if we look inside of this list, we'll be able to see what properties we're actually able to pluck off and look at. So if we do absolute path, and if we do relative path as well, if we hit enter again, we'll see that we're pointing to each of our image files. And now, by using this query, we're actually able to get all of the files that we want inside of our project. So if we wanted to, for example, store different data inside of these files in order to actually represent our blogs, we're able to do so using this all file query. Now, we're definitely going to explore that because this is really how it is that we're going to build out our blogs. There is a couple things that we have to make sure that we do first, though. One thing is that while we're able to see a representation of our files, we cannot actually get the data in those files yet. In order to do so, we have to make some modifications to Gatsby. And what we're going to write is going to be a little bit different than anything else you've probably ever written before. Now, what we want to do is we want to start actually building our blogs. There's a couple things that we have to do in order to set this up. The first is that we have to write the files that will hold the data of our blogs to begin with. So these could just be individual blog posts with some text in them. Now, the way that we can actually build out the blog content and get access to all of the styling is to use something called Markdown. Now, if you're unfamiliar with Markdown, Markdown is what is used to build many of the READMEs that you see inside of GitHub. So you'll see that we have access to these different titles. We got access to the static linking. We can put all of these images inside. And we also get access to these code blocks inside of Markdown. So Markdown is a pretty consistently structured and very supported style of writing text that Gatsby also allows us to use. So if we wanted to write our blogs and get styling, you really just need to learn a little bit of Markdown. And I will give you a Markdown cheat sheet that tells you all of the different styles you can apply in Markdown when you start writing your blogs. But I have some pre-written. So what we're going to do is we are going to make a new folder that is going to hold all of our Markdown files that represent the blogs we're about to make. So go back to your application. And what you're going to do is make a new file inside of your source, a new folder, and we're going to call it Markdown Pages. Inside of Markdown Pages is going to be each Markdown file that represents each blog post you're going to write. So I'm going to make a new one, and I'm going to call it Ice Cream. And I'm going to call it icecream.md. Now, .md stands for Markdown. Now, inside of this, I'm just going to paste my Markdown code that represents the first blog that I'm writing. And I am also going to give you this resource as well, just so that you can walk through with me before you actually make your own Markdown files. Now, you'll notice at the top here, there are these 3 dashes. These 3 dashes represent what's called the front matter. And the front matter is just kind of like some data that you can pull off of this Markdown file and have it represent perhaps some data that you want to display inside of a snippet rather than the entire content of the actual blog itself. This can also hold any metadata. So you can just see the front matter as metadata, and we're going to explore how to actually use it inside of our GraphQL queries. So other than this one, I actually also have another Markdown file that I want to make, and I want to call it myfirstama.md. And similarly, I have the other file here for you. And here you'll see that I'm embedding an iframe. Now this iframe points to a YouTube link of the first AMA that I did a couple weeks ago. But this thing is actually going to be what you get from YouTube as an embed link. So you can put this inside of Markdown as well, because Markdown ends up being compiled to HTML. And that's another great thing about using Markdown, is that using these 2 Markdown files, we're now able to represent our blogs very dynamically. Because if we wanted to write new blogs, we simply just add new Markdown files that represent our blogs. And then after we write the remaining code that will dynamically build out our blog posts, we'll be pretty set in terms of our blog website. Now, the one thing that we do have to do is we have to make sure that we're actually able to access these Markdown files. Because as you remember inside of our config, right now all we're doing with this file system is simply accessing images. If we wanted access to Markdown, we can just duplicate this block of code here, so copy paste it down, except I'm going to change this name over to Markdowns, and instead of the path pointed to images, I'm going to point to our new Markdown pages path. So let's save this, and what you have to do is you actually have to restart your server whenever you change any plugins inside of your config. So while we get hot reloading with a lot of the metadata or any of the files that we change inside of our general structure, we do not get it with our config plugins. If you change the plugin, just restart your server. And once it's finished building, we're going to go back to our GraphQL and we're going to take a look at what it is that we get. So if we refresh now and we hit enter, we still see our original image files, but now we see that we also have our Markdown files. So now that we're able to access the node representation of these Markdown files, let's actually figure out how to pull the data out of them in order to dynamically build out the pages that we need inside of our application to represent these blog posts. And that's what we're going to do in the next lesson. So I'll see you in that lesson. Hello and welcome back. So in the last lesson, we learned a little bit about this Gatsby source file system plugin. So plugins are pretty much these tools that we can include inside of our Gatsby config in order for our Gatsby processes to get these bonus features. So for example, Our source file system, as we know, gave us access to that all file query inside of our GraphQL queries on our web. Now, the next thing that we need to add is actually going to be a new plugin that is called a transformer. The transformer will allow us to take these files that we are pulling into our query using the all file query. That gives us a node representation, but we actually want the data that sits inside of those files. So we need a transformer to do that. The thing that we have to note, though, is that transformers tend to be libraries that we need to install inside of our project. Now, if you look inside of your directory, you might see a yarn lock file. If you see a yarn lock file, it means that by default, this project comes with yarn. If you see a package lock file, then you actually don't have yarn installed. Instead, what you're using is just npm. What we're going to do is we're just going to add this new file, and depending on what you have, whether it's yarn or npm, just use the respective one. In order for you to add a new file in npm, you do npm install, and then you type the name of the file, or the package that we're adding. If you're using yarn, you're just going to do yarn add, and then the name of the package that we're adding. Now, the name of the package is Gatsby Transformer Remark. So simply add that in with your respective package manager, depending on how your folder structure looks. And what this will do is this will add in this new transformer object that we need to plug into our application. So you simply add these backticks here and you type in Gatsby Transformer Remark. Now, what Gatsby Transformer Remark does is it is a plugin that allows us to convert our markdown files into data and HTML. The front matter portion of our markdown will get converted into a data object that we can access, and everything in the actual markdown itself will be converted into HTML that we can use to build the pages that we want inside of our application. Now, keeping this in mind, the other thing we have to do is remember to restart our server because we've added a new plugin. In order for us to actually access what we're going to see with our transform remark is that once this server finishes rebuilding, we get access to this new query inside of our GraphQL. So let's just wait until this finishes building. And we'll go back to our GraphQL and we'll refresh. Now what we'll see is this thing called all markdown remark. So if we add this and we simply fire this off, we see that now we only get 2 nodes. The reason for this is because these are actually our markdown nodes. So in order for us to see inside of the node itself, here we have our front matter, where we have an optional description, the title, and the date, as well as this HTML block, which represents the actual body of the markdown that we've written. So we fire this again. Here we see that the HTML holds the markdown, but now converted into HTML, as well as our front matter object that holds our description, our title, and our date. Now, description, of course, is optional. That's why in some places we get null because we don't include one. So we just have to account for this when we actually build out our blog template. Now, another property that we see that we have is this excerpt. Now, the excerpt, unlike the HTML, is what will give us this little snippet of what we're trying to show. So this is pretty much the body of our markdown, except it truncates it automatically for us. Now, this is really good when we want to actually show or highlight something inside of our blog preview, for example, where we don't want to show the full body, but maybe just an excerpt from the top of it. So we want to use this property inside of our index page, for example, where we actually list out our blogs. So what we're going to do is exactly that next. We're going to go to our index page, and what we're going to do is we are going to bring in the GraphQL query so that we can actually start requesting for that data that we just wrote inside of our GraphQL. So what we want to do is we want to copy this GraphQL, and then after where we export out our actual index page, we want to make sure that what we export is a query. So we're just going to export const query, which is equal to this GraphQL request. And inside, we're going to say it's a query. And then we're going to copy over this object that we wrote before. Now, Gatsby is smart enough to know that if you export out something that has this GraphQL almost body to it, that this is probably a query that you want to use and pass into whatever component you're exporting out by default. Now, we still have to export out our component by default. And if we want to make this a bit more clear, we don't have to export it like this. We can just copy our export default text and replace this index page like so. So by default, we're just automatically exporting out our function that represents the actual component that we want to render for our index page. And now what we're going to do is we're going to get in that props object. And on that props object will be the data object that is our query return. So using that data, we're going to now end up creating some kind of default look to our index page that shows us our list of blog posts. So what we're going to do is we are just going to make sure that there is a div here. We can actually keep this SEO at the top. It doesn't really matter. And inside of this div, we are going to have an H1. And in this H1, we're just going to say Yihua's thoughts. Now, we do also actually want the total count of our blog posts. So in order to do that, let's actually first remove this. And what we're going to do is we're going to add a new property to our all markdown remark called total count. Now, this actually exists right here on our all markdown remark as a property called total count. And as you'll see, what we'll get is the number of nodes that exist inside of this markdown remark. So by doing this, we're now able to access it inside of our data object. So we're just going to make an H4 that says a JavaScript interpolation of data.allMarkdownRemark.totalCount. And now if we save and we go back to our actual application, we see that we have our count here. Now, let's actually log out the data to see what else we have access to before we continue. Because the shape is actually going to represent the query, but let's just make sure. It doesn't hurt to always double check. Now, if we open up our console, we'll see this object that represents our data. On it, we see our all markdown remark, and inside of it are edges. Inside of our edges array is each element that has our node property, and then on the node property has those fields that we requested in our query. So as we can see, the object that we get back resembles the exact shape of the object that we passed into our GraphQL query. So this format matches exactly this format. So that's really great for us because now we know roughly what it is that we need to use on this element in order to actually build out our blog previews. So what we're going to do is we are going to make another JavaScript tag, and we're going to say data.allMarkdownRemark.edges.map. So we want to map over each edge. And on each edge, we want the node object that we saw. So each of these. And what we're going to do is we are going to return back a div where the key is equal to the node ID. And then inside of each div, we're going to have a title. So let's just use an H2 for now. And what we'll render right here is our node.frontMatter. Actually, this might be lowercase all dot title. And we're also going to put a tab here that also loads the date. Actually, instead of an H2, let's use a span, just so that it's not too big. And then after we have this span, we are also going to put a p tag. And in the p tag is where we'll put our excerpt. Now, if we save and we go back, we see that our blog data is showing up. So it's not styled yet, but so far it's all perfectly fine. So that's one of the great things about Gatsby, is that by leveraging the flow that Gatsby expects us to use, as well as tinkering around with some of the code, we're now able to pull in our markdown files as the data that we use to actually populate this index page. So this is great because whenever we add new Markdown files now to that Markdown pages folder, we will automatically be able to pull it into our index.js with our GraphQL query. And as you would expect, our data would simply just populate out and give us new blog samples inside of this index without us ever having to modify that code. So this is really great. Now in the next lesson, we're actually going to build out these blog post pages individually because right now we can't link to them. We're simply displaying it in our index. So let's do that in the next lesson. Welcome back, everyone. In the last lesson, we learned how to use GraphQL to pull in our Markdown files and then use them and their data to populate out this list of our blogs. Now we're only displaying the excerpts, so we're not actually explaining the body of our blogs. We're going to do that in an individual blog page. And the way we're going to do that is we're actually going to need to leverage this new concept where what we're going to do is hijack the build step whenever we built out our Gatsby blog, when we ran yarn develop for the first time. We are going to come in here when it creates those nodes, which represent the files that we've written in the first place. And we're going to grab the Markdown and we're going to build out each individual page at that moment. In order for us to do this, we actually need to modify our node Gatsby file. So in here, you'll see that there's this Gatsby node.js. In this file, this is code that will run theoretically on the node server that represents the Gatsby framework. Now, two things to note here. The first is that the code that we're going to write is not React code. So it might not be something you recognize if you are only used to writing React. There's a little bit of backend node code here that we're writing, but it's not completely node either because it has to do with the node API inside of Gatsby. So you can easily take a look at the documentation here if you follow this link inside of your Gatsby node.js. But let's just get started because once we actually write this code, I'm certain you'll at least be able to follow along with what's happening because it is JavaScript. So let's just get rid of this. And what we're going to say is exports.onCreateNode. So Gatsby is expecting that if you export this method onCreateNode, it is equal to a function, and they're going to pass this function a bunch of properties, one of them being the node itself whenever it's creating the node. Now, as you remember when we did our GraphQL query for our files, each file had a node, which was a representation of that file. So what we're going to do is we're just going to simply console.log that node object. There's a property on there called internal, which just represents data about the actual node itself, and we want the type. So now, if we refresh our server, what we're going to see is when it's building, we see this list of all of these different things that we're logging out. Now, these are all the types of node that we have available. And the main ones that we want are the Markdown remarks, because as you remember, the Markdown files is what we want to use to build out our pages. So what we're going to say is we're going to say if the node.internal.type is equal to Markdown remark, then what we're going to do is we are actually going to create this thing called a slug. A slug inside of Gatsby is the URL or the link that the browser is able to access from our application in order to navigate to the page required. Now we have to dynamically build out the slug and attach it to the node as a field because we want to access that field inside of our application so that whenever we try to route to it or link to it, we are always pathing to the correct path. So we want to build that path out dynamically. We actually get access inside of this onCreateNode function, this other property called actions. And these are actions that we will receive from Gatsby. The one that we want to pluck off is this action called createNodeField. CreateNodeField is exactly as it sounds. We want to add a new field to our node. So we want to destructure this off of our actions. And what we're going to do is build the field path to our node. This field path is what we're going to be using inside of our application to navigate to this page. Now, the only thing to keep in mind is that inside of Gatsby, this thing is called a slug. And a slug is essentially just some kind of file path or navigation path inside of the application that allows us to route to it. we actually get access to this function that we get from Gatsby source file system. Gatsby source file system, as you remember, was this plugin that we used to actually get access to our files in the first place. So in order to bring it in, we are going to destructure off create file path from this Gatsby source file system. You'll see here that I use backticks. Now, backticks is actually what Gatsby prefers you to use when instantiating strings. In fact, we should probably change our markdown remark over to using backticks as well. And this is simply due to the prettier configuration rules that are set with Gatsby when we loaded it by default. Now, you can actually find these rules inside of this prettier RC file in your base root folder. And prettier, if you're not sure what that is pretty much just a tool that allows you to consistently enforce certain typings and stylings regarding the way that you write code. Prettier is really great if you have an application with many developers that have different ways that they like to write things. With Prettier, whenever you save or whenever you actually type anything, you might get warnings telling you that you cannot do certain things. So for example, if I ever try to make this a single string, whenever I save Prettier, we'll force that to be double quotes. So if we switch over to using backticks, that's perfectly fine too. You'll actually find that when you look through your Gatsby files, any file that gets generated by Gatsby is using backticks. So it doesn't hurt, it doesn't actually impact performance in any way. So let's just switch over to backticks. But now that we have our create file path function from Gatsby source file system, what we want to do is we actually want to generate that new slug. Now the slug itself, as I mentioned, was the route. Now the route, we're going to use our create file path method. And what this create file path method takes is an object as the argument. The first thing it takes is a node as the first property. The node property essentially just points to the actual node that we're trying to convert into a file path. So as you saw with our pages, what Gatsby does under the hood is it takes the name of the actual file and it turns it into the literal name of the route to that page as well. So if it's page-2 as the file name, the actual route to the URL is also page-2. So we're going to pass it the node. We're also going to pass it the method that it needs to fetch the node. Now this is pretty much in the API docs and you just have to follow along. What it does is you have to get this getNode function that we also get from onCreateNode. And we're going to pass that as the second argument. GetNode is just a function that allows you to pull the actual node object representation of a file or an edge. Now you remember when we looked at our actual GraphQL, we saw that we had nodes, right? And then we have these edges. GetNode is just a way to get this literal node object. It just uses it under the hood to actually get the required node that it wants. Third field is an optional field, which is called base path. And base path is something that you add when you want to add a base path to the URL. In our case, there's no need for it. So we can just ignore that property and just pass this in as our slug. Now we're finally going to actually create the node field on our node. So what we're going to do is just call create node field. And we're going to pass this an object where the first property is the node pointing to the same node. We're also going to put the name. So this is the name of the property that we want to add. And we want to add it called slug. And the value is going to be the slug itself that we just created using create file path. So with this, whenever we actually end up creating all of our nodes, we will end up appending onto that node a new slug property with the value of our string. So now, if we actually restart our server and we check out our GraphQL once this is finished, we'll be able to see it on all of our markdown nodes, that new field that we added. So let's just let this finish building. Okay, now if we refresh, you'll see on this node that there's this new thing called fields. And in fields is slug, which is our new property that we just added. So any field that you add to a node goes under this fields property. And now if we refetch, we'll see inside of our slug, we have the actual route that we need to use to navigate to the actual route path that we declared. Now what we have to do is actually build the pages dynamically, because now that we've set up our node, we have to actually set up the actual page that we build. So we'll do that in the next lesson. Welcome back, everyone. In the last lesson, we learned how to hook into this onCreateNode method inside of our Gatsby Node.js. This method allowed us to hook into the build process when Gatsby would go through our files and build out the individual node representations of them. And then we were specifically looking for nodes of the type of markdown remark. We then added this new node field on it equal to slug, and the slug pointed to the new file path that we made. So now that we've modified these markdown nodes, we have the actual slug value that we can access inside of our application. And in this lesson, we actually need to use that because we're going to build out the final pages that our markdowns represent inside of our website that point to the actual blog posts that we want the users to see. So just like we saw with our pages folder, which had any files that we wanted to represent as the final page that our users could see, we're going to do the same thing with our markdown files. So one thing that we have to know is that we have to use another method inside of our Gatsby Node.js. I'm going to give you documentation to this API so that you can see any other methods you can access, and you can also look up anything that we've already used before to get a better understanding of it. But the next one we're going to use is called create pages. And create pages gets two arguments that we want to destructure off. The first one is just GraphQL, which is pretty much the same way that we've made GraphQL queries before. We can just now do so inside of our Node.js. And the other thing we get is actions. Now, what we're going to pull off of these actions is the method create page. Create page is an action that allows us to actually build the pages inside of our application based on whatever properties we pass to it that we'll discover once we actually use it. So what we want to actually return from our create pages function right here, though, is we want to return a GraphQL query that gives us back all of our markdown remarks. Then we're going to iterate over it and simply just call create page on each of those markdown nodes. So in order for us to do this, we have to use the GraphQL query that we got back. So to use it, we're just going to say GraphQL, and then we're going to pass it with these parentheses. Now, if you're curious as to why inside of here we have to use these parentheses, whereas inside of our front end React applications, we don't, this is because there's a new template syntax in ES6 that allows you to pass template literal strings like this in the front end, as long as you have access to ES6, which is pretty much equivalent to doing this. There's really no difference. But because with Node.js, we do not get ES6 features right out the jump, we do not have access to writing it this way. So we have to pass these parentheses, just if you're curious as to why here we have to do it. So that's just one thing you have to remember if you ever use the GraphQL query inside of your Node.js. Now, there are setups that you can do with Node.js and Express so that you do get to use that same syntax as you are familiar with in your front end. But in our case, it's not necessary. It's extra work that really, just to avoid adding these parentheses, is not worth it. But now that we have our GraphQL query, we have to make the actual query for our all markdown remarks. So we're going to do this inside of our graphical, just so we can actually see this. So inside of your playground, what you're going to do is you are going to click all markdown remark. We want the edges. We want the node from these edges. We want the fields, and off these fields, we want the slug. If we fire off this request, we see that this is going to be the object we get back. We're going to need to pull off this edges array and iterate over this so that we can call create page using each of these node objects to build the actual page, because this holds the data that we need. So let's just copy over our query object. We'll go back to our code and just paste this in. Now, GraphQL, the method will simply return us a result inside of a promise. So once this resolves, we just call .then on it, and we will get the result value. And off of that result value, it will be that shape that we saw. So we want to look at the data, and off the data, we want our all markdown remark. And all markdown remark, we want the edges array. So we just want to loop over this array with for each. And for every element inside, we want to pluck off the node because that's all we need. Now with this node, we are going to call createPage, and we're going to pass createPage an object. And this object is going to define the properties that this createPage needs in order to actually build out the page that we're looking for. So the first thing it needs is the path. The path will tell it in the final application what path actually leads to this page that I'm building. And this is where we're going to use our slug. So we're going to say nodefields.slug. And here we're going to pass the actual component. Now the component is going to be the template that it uses in order to actually populate out the final blog post. So this is pretty much going to be a React component. And here we're going to make the new blog post template that we need to use for this context. So we do want to keep this component that we're going to build separate from our front-end components because it will only be used inside of our Gatsby Node.js file. So we'll make a new folder called templates. And inside of here, we're going to make a new file called blogpost.js. So normally you might be used to every React component that we write being .jsx. And this is totally valid too if you want to make it .jsx. But because every single React component that we have inside of our Gatsby folder is a .js file, for consistency's sake, we'll just use .js. Babel knows that if you have React inside of your JavaScript, it will convert it to regular JavaScript. So it's not a big issue. It'll still work. So here we're just going to say blogpost.js. Now, because this video is getting too long, let's just break this up and continue this inside of our next lesson. Now we're going to build a pretty simple template. So what we first need to do is import React from React. And we're also going to import in GraphQL from Gatsby because we need to make a request for the actual markdown. We're also going to import the layout from our components. Now, if you're curious why this template is not in our components folder, the reason is because this template is not a component that we actually use in the application. Any application files we keep inside of our components, but anything that we use to actually build out our blog posts or any other templates that we dynamically generate in our Gatsby node, we're just going to put here instead. What we're going to export as the default is going to be this new function where we get the data, because we know what we're going to want to pluck off is the markdown. The actual GraphQL that we need is going to be this query. Now, what we want to query for is the individual markdown remark related to the slug that we get. We're actually going to get that slug manually by passing in it as a parameter that our GraphQL will use. So I'm going to show you what the GraphQL looks like, and then when we go back to our Gatsby Node.js, you're going to see how we pass that in. So essentially, we're going to have our query, and it's going to receive this parameter called slug that's going to be a string, and it's always going to be mandatory. Now, what we're going to get back is a markdown remark, where what we're looking for is we want to match this fields here to the slug value, right? And we want it to be equal to the slug parameter that we pass in. So if you're unfamiliar with GraphQL, this is the syntax of writing a query. Essentially, we're specifying that I want you to match this field on our markdown remark where the slug is equivalent to this slug string that we pass in here. Now we can actually test to see if this query works first. And we can do it inside of our GraphQL playground. So let's just get rid of our initial query for all markdown remarks. And what we're going to request for is simply a markdown remark. And inside here, we see that what we did was we checked for the fields, we checked for the slug, and we checked that it was equal to some string. So in this case, the string that we're matching will be either ice cream or my first blog. And now, whenever this logs, I also want to make sure that I get the ID, and I want the fields as well, and I also want the slug here. So now if I do this, I see that I'm fetching for exactly the markdown that matched the ice cream slug to this string, which was our ice cream markdown. So that's really what we're doing here. So what we're doing is we are getting that markdown, and what we want to plug off of it is the HTML. We want the front matter, and we want the title. So with this, we now have the data that we need. And what we're going to do is we are going to set the post itself equal to data.markdownRemark. So now we have access to the markdown remark object. And what we're going to return is our layout component wrapping around some div that holds inside of it an H2 or an H1. Let's do an H1 actually. And as you can guess, we're going to do post.frontMatter.title. And then for a div, this is where we're actually going to populate the div with our HTML. So we're going to use a React method called dangerously set inner HTML. This is the preferred way of actually setting this value. So I know it says dangerously set. This is because in typical React, you don't want to do this, but in Gatsby, this is perfectly fine because it's not dynamically generated. This is statically set. So __ HTML is the value, and we want post.html. So we want to use the HTML value here. And what this will do is this will set all of the HTML value inside of this div. So with this, we have our blog post template. So let's go back to our Gatsby Node.js file. And inside of our create pages that we had before, we are going to now pass the component. Now, this component is expecting a relative path. So we actually have to build it using the path variable that we get by default from the path library that comes with every single Node.js file. So we're going to pass in path, and we're going to say path.resolve. And what we're going to say is ./source. So I want to go from the root down to the source folder into templates using our blog.js. Now, in order for us to pass the actual slug value to this query, we pass it through this context object. And here we're going to give the slug equal to our node.fields.slug. So now this will know that when it runs create pages, what it's going to do is it's going to create the page calling GraphQL using every single markdown remark. It's going to loop through every single markdown file that we have, and it's going to manually create a new page for it using that new blog post template. But now we have our new create pages method. There's actually a typo here. This actually should be S. In fact, let's just double check our blog post to make sure that we're not doing anything wrong. Oh, it looks like I actually used the wrong parentheses here. So let's just fix that as well. We want to make sure we're turning with round brackets. Okay. So now let's restart our server. So let's just wait for our server to finish building. Okay. So now that we're finished building, let's actually see if our pages have generated. So let's go to localhost 8000 and let's just navigate to our pages. So the first is ice cream, and we see that we have it. And our second is my first AMA. And here we see that this also works. So we now have our dynamically built pages using our markdowns. If we write any new markdowns to our pages, not only is it going to add to our index, but we're going to generate a new page for it. So this is awesome because now we've pretty much got a dynamically structured and building blog without us having to add any more code other than some styling if we want to or new features. But as far as it goes in terms of adding new blog posts, this is pretty much done. One other thing that we're going to do is we actually probably should reverse the order of this listing. Because right now it's listing the earliest dates first versus listing the latest dates as the newest things. So we can do all this in the next lesson. Welcome back, everyone. So in this lesson, we are just going to add some finishing touches to our blog code. So in our index.js, we currently need to sort the actual blog posts themselves so that their order is more based on the date, having the latest be the ones at the top. Now, how we can do this is we can actually use a sort method. The sort method is inside of GraphQL as well, and it allows us to sort by some specific field value. And in our case, the one that we want to sort off of is our front matter ___ date. And the order that we want it to be in is descending order. Now, if this is confusing, you can actually see this as well inside of GraphQL. So if we were to take our all markdown remarks, and here we check to sort it. Inside of here, we see on our sort that we sort by some field. And if the field that we want to sort by is date, what we have to do is say that it's based off of front matter date. You see right here, this autocomplete __ date. That's how we access a property that sits inside of an object on the field. Now, after this, we want to sort by the order, and we can do descending or ascending. So that's what it is. So by this, automatically now, this is sorted by descending order. We can double check by checking the front matter date value. And now we see that the latest ones are at the top. So that's all we're doing here. We're just sorting this by this order. Now that we have all of the data, the other thing that we want to do is be able to link to our pages from these components. So what we can do is we can also pluck off the fields and grab the slug from the node itself, because as we know, we've added it in now. One other thing that we might want to do is actually style this page so that it looks a little better. The way that I'm going to suggest you do it is with style components, but you can totally do it with any other styling that you're comfortable with inside of React. So in order to actually add in style components to Gatsby, there is a Gatsby plugin that allows us to add style components really easily to our Gatsby folder. So what we'll do is let's just cancel our server first. And just like before, using the package manager that you've been using up until now, for you, it's either yarn or npm. I'm using yarn, just add in these 3 packages. So I'm going to say yarn add Gatsby plugin styled components, which is the Gatsby plugin for style components. We need styled components itself. So this is the style components library. And then I need the Babel plugin styled components. So we need these 3 in order to properly run style components inside of our application. And once it's finished installing, what we're going to do is modify our Gatsby config so that it includes our Gatsby style components plugin. And all we do is we just add it somewhere here. I'm just going to put it right here. And it's going to be our Gatsby plugin styled components. And now we're able to load style components into our application. So what I want to do is write style components for my index.js. Now, in order to use style components, we just need to bring it in. So we are going to import in styled from styled components. And then what we're going to write is we are going to make our blog link. So we've imported in the slug. We now actually need to allow our title to be clickable in that way. Now, the first style component I'm going to make is a blog link. So this is pretty much just us using the style component library wrapping around the link component that we get from Gatsby. And what I'm going to say is I want to apply the styling of having no text decoration. The reason for this is because the link is actually just an A tag with some modifications on it. So in our case, I don't want any of the styling that comes with an A tag. After that, I'm going to use it to actually just wrap around the actual span tag that we have here. So I'm just going to put in my blog link. And this is just going to navigate us to our node.fields.slug. So now our blog link actually points us to our slug field that we have. After that, I'm going to make another one called blog title. And this blog title is just going to be a styled h3. And on this component, I am going to put a, let's just say a margin bottom of 20. Let's actually make it blue as well, just so that we can see the changes. And then I'm going to replace this span with it. Now, if I save and we go back to our application, we'll see that our links are now clickable. And they take us to our respective blog post. That's pretty much all that we need to do in order to actually build out our blog. Now, the last thing that you might want to do is host this somehow. Gatsby is actually really great with another service called Netlify. Netlify allows us to host static websites and get continuous development pretty much for free. And the easiest way to do that is you just first instantiate a GitHub repo that you put your code into. So we're just going to make a new repo, and I'm just going to call it new Gatsby blog. I am going to just copy this key. So if you don't have SSH set up, just use HTTPS. It's about the same. And then I'm just going to make sure to run git add -a git commit, adding all our new blog code for Gatsby setup. And then I'm going to git add remote origin and then paste in that key that we just copied. Oops, sorry, git remote add origin and then paste that key. So now that we have our remote origin, I'm going to run git push origin master with the new code that we have. And now that we have this set up, what we're going to do is we simply go to Netlify. Now, on Netlify, you have to sign up. If you haven't signed up, just make sure to do so. Once you've signed up, just make a login. And now it's so incredibly easy to actually set this up. So what you need to do is just make sure that your code is actually on the new site that you've got in your repo. So we see that my code is now inside of my new Gatsby blog repo. And what I'm going to do is just click this new site from Git. I'm going to select GitHub for the continuous deployment option. And it's going to ask to authorize me. Now, you probably have to allow it to authorize you to connect to your GitHub. And what you're going to do is just find the name of your actual repo. Once you have it, you click it. By default, all of these settings should be good. It's going to run the Gatsby build. And once you click deploy, that's it. It's in the process of building and deploying your website. And once your website's finished, it's going to give you the actual link that tells you what your site is hosted to. So let's just wait for our website to finish deploying. Okay, so now that it's finished, we see that we get our URL. We simply click it, and now we are live with our blog. So if you actually want to make any changes, it's super easy because all you do is you just write the code, you push to GitHub, and automatically Netlify will restart and reboot and redeploy your website. So here I actually didn't add in any posts. So what I'm going to do right here is I'm just going to add the word posts. I'm going to save. I'm going to git add added word posts. I'm going to push. And once this pushes up to my GitHub again, if you go back to Netlify, you might actually see when you scroll down here in production deploys that there's this new second tab for another production. So this is actually a list of all of the deployments that are being made. Now yours might say in queued or it might see in progress. Mine just got published. So now if I go back to my blog and I refresh, I see the word up there. So this is awesome because Netlify just immediately gives you continuous development right off the gate with your GitHub account. And it was so simple to set up. So with this, you pretty much have your blog. All the code is written. You can pretty much use Styled-Components or any other styling system you want and tackle the coding challenge as you please. So good luck, everybody. And I hope you enjoyed this lesson on how to use Gatsby. Now, before we continue, I just want to bring up something very important. So in this course, we will cover extensively many concepts in React, but also a lot of concepts in JavaScript, because they will fundamentally play a large role in how we understand the code that we're writing. Now, the first things I want to focus on are actually array methods, particularly these 5. Map, filter, reduce, find, and includes. Now, we may not cover all of them right away because we're not going to use, for example, reduce until later in the code. But I want to cover the ones that we will encounter immediately. So even though I'm showing you these 5, don't worry if you feel like you don't know them all right away. I'm definitely going to cover them just before we have to use them. Or whenever we do use them, I'll explain it then. But this is an important concept, the idea of array methods. The reason for this is because we will use them a lot inside of our React code. Array methods are methods you can call on any array that will perform some kind of action on that array or with that array. So I will explore that a little bit later, but the way that you use these methods is you take any array. So let's say we make a new array called myArray, and it's equal to an array of these 4 numbers. You're able to call myArray.map, .filter, right? .reduce, .find, .includes, and inside you would pass it something that it needs in order for it to work. Now, every array method takes something different, which we'll explore, but this is how you use them. Now, the first one that I definitely want to cover is map. So in order for us to understand map, let's go to our browser. Now, inside of our browser, we want to access the JavaScript console. So in order to do that, we have to right-click and click Inspect. Now, if you're familiar with the dev tools, you'll know that the console is right here. But if you're not familiar with the dev tools, this is a great tool that we're going to use to see how our web application is either performing or how it ends up being rendered. But there's lots about this tool that is a very good lens for us to use to see how our application is doing. But for this case, we're going to click this console tab up here to go to the JavaScript console. This allows us to write and run JavaScript code because the browser supports JavaScript. So what we're going to do is we're going to declare our array again. So const myArray equals an array of 1, 2, 3, 4. Now, what we want to do, for example, to better understand what map does is to understand what we're trying to get to. So let's say we have this array. What if I wanted to increase the value of each element in this array by 1 so that I get an array of 2, 3, 4, 5? How do we do this? Well, one way might be to write a for loop, which we're familiar with, right? We might write something where we loop over the array, we get the value, right? And then we increase it. But that's kind of very similar to what map does, but in a more efficient way. Plus map gives us a new array back. So what we would write is map myArray.map, and then inside we pass a function that gets called on each element in the array in the order that they appear. We actually get that element in our function as the first parameter of our function. So our first parameter being the element. And then whatever we return from this function will be the value in our new array in the place where that element was in the original array. So if we do element plus 1, then we'll get 2, 3, 4, 5. Because we're just taking the element from that place and adding 1 and returning it in a brand new array. We don't even have to use the element. We could actually, instead of mapping with the element, right, we could pass nothing through and just return the letter B. And what we'll get, don't need the return. And what we'll get is B in 4 places where this function was called on each element in the array. But this is also a new array. We know this because my array is still 1, 2, 3, 4. So this is what map does. It lets us create new arrays based on our existing arrays. And this is really handy, and we'll use it extensively when building our application. Before we continue, I think it's very important for us to take some time to better understand JavaScript asynchronous event handling. Now that's a mouthful, but asynchronous event handling is a huge part of not only JavaScript, but also the React ecosystem. Now, with ES6, there was promises that got introduced as a means of handling asynchronous events. We've already used them a little bit when we used fetch in our Monsters-Rolodex project. But let's take a deeper dive into both fetch and promise, as well as the new ES7 syntax of async await. These are three things that we're going to use a lot in our application. So let's first look at what we had before promises so we could understand how promises work. Now, I've got some pseudocode here, but you can imagine what it is that this code is trying to do. We have some function called getUser, which fetches it from this link, right, of Facebook/Yihua. So we're fetching our Facebook user, Yihua. And then we give it this function, which is called a callback. Inside of it is either going to get the successfully retrieved user or an error if something goes wrong along the way. If there's an error, we want to throw the error, right? If there is no error, then we want to get the user ID and set it to this constant of user ID. And then we want to pass that into this new function, getFriends, where we give it the user ID, right? And maybe that fetches friends from whatever backend API it is, right? We don't really care. And then we give it also another callback. But this time, similar to what we just did with our getUser, it's either going to give us back our list of friends, or it's going to give us back an error if something goes wrong. We'll do the same thing, right? If it errors, we want to throw the error because we want to stop our code, right? If there is an error. And then we want to get our friend John from that list of friends if there is no error. We want to do some find, right? However it is that we get him. And then we want to get his posts in a similar method as the one before. We give posts, John, right? It gets it from whatever backend, and then we give it another callback. Posts, error, if error, throw the error, right? If there is no error, I want the first post, and then finally I want to get the comments for the post. Similar method, similar callback, before we finally end up displaying the comments. So this is as much of a mouthful to say as it is to read. Reading this code is really difficult because it's this massive pyramid tree-like shape of nested callbacks. And what we affectionately refer to this as is callback hell, because this code is extensively difficult to read and debug. Now, with the introduction of promises, its aim was to extrapolate out a lot of this stuff. And the reason for it is because this code here, these functions, are all asynchronous functions. We don't know when those functions will complete. And we have to nest a bunch of other function calls inside of each other because each one depends on the result and the return of the previous one. In order for us to get our friends, we need our user ID, which we get after we fetch it, right? And then in order to get the posts, we need to get our friend after we've gotten our friends list, after we've gotten it from our user. Like, it's just this long, repetitive process, but this is also part of our coding. A lot of the times, this is what we'll need to do in order to eventually get that right final set of data we need. So promises has simplified this, and promises was introduced in ES6. So let's take a look at what it is. So let's get rid of this for now. Now, a promise is instantiated with this constructor. So we'll say const myPromise is equal to new promise, and then the promise is given a function. And in this function, it gets passed two things, a resolve and a reject. Now, what is the resolve and what is the reject? Well, a promise is kind of exactly as what it's named. It is a promise that this object will eventually have a value. It will either be a resolved value or a rejected value. The resolved value we use when our API call, for example, is successful. Our reject call we use when our API call gives us an error. But the promise will be in a state where it's pending until either the resolve or the reject has been called. Now, what does that mean? So let's say we have some set timeout. And set timeout is just this function that takes a callback and a time as its second argument. That time is in milliseconds. So we're saying after 1,000 milliseconds or 1 second, we want to run this function. And the function we want to run is resolve with the term I have succeeded. By doing this, we are saying that after 1 second, I want this promise to call the resolve key with this value of I have succeeded. So when this happens, when resolve finally gets called after 1 second, our promise now holds this value that we pass to the resolve. And in order for us to access it, we have to say my promise dot then, and then we pass the dot then a function where value will be the resolved value. So now we can finally console log the value. Now let's open up our terminal and run this in C. Let's say we run our code. We will see that after 1 second, it logged I have succeeded because our promise has resolved this value. Now reject will work in a similar way, except in how we end up accessing it. What we would do is, let's say we have some call where we say, let's say we have a conditional, and we'll just set this to true for now, right? If it's true, then we want to resolve our code. Otherwise, we want to reject with I have failed. Now, if we set our conditional to false, right, we will hit our else block and it will reject. And the only way for us in our promise code following the instantiation to access the rejected value is to chain on a dot catch. With the dot catch, we will get the reject value inside of the callback that we pass to it. So if we were to console log it, then now we will see we get the I have failed. So what we're getting with this promise is control over what we want to do with asynchronous events if they succeed or fail. Now, sometimes if we're just using set timeout, there's no reason to reject, and that's perfectly fine. If we just want to defer our promise's resolution, right, and we're using a set timeout, and there's no reason to reject, that's perfectly fine too. There's no need to call reject, right? We can only just resolve. But by having reject, we are able to control the separation of a successful API callback from an unsuccessful API callback. And that's the main benefit of using promises, is because when we make an API call, we don't know whether or not that'll work 100% of the time. If we call a server, we don't know if that server's down. We also don't know if we made a mistake in the parameters that we're passing in that API call. Let's say our backend is expecting a user ID, right? When you fetch at a certain endpoint. You don't give it the right server ID or you forget to give it an ID. Then that API call will throw you back with an error saying, that's not right. You didn't give me a user ID. Well, we want to handle that differently than we want to handle a successful API call. And that's why we have both this resolve and reject. because we're able to separate our concerns. Our success is in the then callback, and our failure, our error, is in the reject callback, which is in our catch. There's another thing that we can do with our promises. We're actually able to chain .thens together because the callback that we pass to it, whatever gets returned, right? In this case, we're returning console log, which actually doesn't return anything. It just returns undefined. But let's say we were to return our value, but we want to add a bunch of exclamation marks to it, right? So we're returning a new string plus 4 exclamation marks. What .then will do with that value is it will wrap it inside of a resolve promise. That way we can chain .then on it with our new value and then console log that new value because the .then has wrapped this value in a resolve promise. You can only call .then on a resolved promise, right? You can't call it on a normal string, right? And the only reason we're able to do so is because each .then is wrapping the value that gets returned from the callback that they get passed in a resolved promise. Now, we can do this as many times as we want because every .then will be wrapping that return in a resolve promise. And we actually have seen promises before. If you're keen, this actually looks a lot like when we used fetch. If we look at this code, we see that fetch looks very similar to the promise code we just wrote. The reason for this is because fetch returns us a promise. When you call fetch, it's returning you a promise value, while it makes an API request to the URL that you passed it. If the endpoint, for example, throws an error, like let's say we don't have the right permission to access it, or the server is down, or we misspelled the actual end URL. Well, instead of giving us back a value, fetch will actually also reject that value in the promise that it gives back to us. If it's successful, it instead will resolve it, which is how we're able to get a .then response, because that response is what that fetch gave us back. We convert it to a JSON object, right, by calling .json on response. And as I mentioned before, it ends up wrapping that JSON value in another resolve promise, which it then passes to the next .then, which we then finally console log. So if we were to look, that's what's happening here. That first promise is what gets returned from the fetch, a pending promise, right? Because it's not resolved or rejected. But once that comes back, it's successful, it resolves it internally, and then the .then gets called because it resolved. If we were to say, mess up this URL, right? So now we know it's false, right? If we made the catch instead, let's not console log the error because the error is quite ugly. You can imagine we do whatever we want with the error, right? But I'm just going to console log the string I have errored. If we run this, we'll see that the I have errored string was the one that got console logged because the .catch occurred, right? Because the get call from our fetch failed and it came back with an error, and internally fetch rejected that error on our promise object. Now, while the chaining of our promises is rather easy, there is a little bit of complexity when it comes to figuring out how to structure our actual promise wrapping. The good news is that with ES7, there was a new function that was introduced called async await that allows us to better handle how we write our asynchronous code. So let's take a look at that now. Now, the next one we're going to look at is filter. So to understand filter, let's go back to our browser console. So filter is very similar to map in the sense that it's also going to take a function that gets iterated over each element in our array. So let's do this again. Except this time, I'm going to say my array is equal to 1, 3, 5, 7, 9. Now, filter is exactly as it sounds. We want to filter out the elements in our array based off of the function that we pass it. And filter will also give us back a new array instead of modifying my array. So what we're going to do in order to use filter is we're going to write .filter, and just like earlier with .map, we're going to get the element as the argument of our function, and what we're going to return is actually a true or false value. So let's say, for example, I wanted to filter out anything that was less than 5. Well, I would essentially say if the element is greater than 4, right? So whatever returns true will be the thing that gets kept in our array. So whatever element will get kept in our array is based on whether or not the evaluation of this is true. So if, for example, we just return true, well, we would get back our whole array. If we return false, right, we would get back nothing. So if we wanted just whatever was 5 or greater, then we would say as long as the element is greater than 4. Because if the element is 1, 1 is not greater than 4, right? So that will be false. And that's why it'll filter out 1 and 3. And this array that we get back is a new array. My array is still the same array. And that's what filter is. So remember that. Filter also returns back a new array, except it filters out anything where the function's condition returns false. Anything that returns true, it'll keep in the new array. Okay, now let's talk about includes. Now, includes is a little different from the way that we've been writing the other array methods that we've covered so far. Includes is essentially a method that takes a single argument, and that argument will be any element that we want. And what it does is it checks inside the array to see if the element that we passed it exists in our array. So let's try this out. Well, let's first make our array, which is equal to, let's say 1, 2, 3, 4, 5. If we do myArray.includes 3, we'll see that it's true because 3 does exist in our array. Now, if we were to say try something like 9, then we would get false because 9 is clearly not inside of our array. The second argument we could take in our includes is the index in which we want to start searching. So what do I mean by this? Well, our array is actually indexed from our first element to its last element starting from 0 and counting up by 1. So 1 is our array element at index 0. 2 is our element at index 1. Now I know with this example, maybe it's a little confusing. So let's do another array. Let's use const new array equals these 3 objects. Well, new array at index 0 is our first element, right? Our first object, ID 1. Element at index 2 is our last one because this is 0, this is 1, and this is 2. One thing to keep in mind with using includes and our second argument, let's say in our original example with myArray, we wanted to see if the number 2 exists starting from our third index. This means that it's starting from 4, it's going to check if 4 includes R2, it doesn't, or R5 has R2, which it doesn't. So here we'll see that we will get false. So essentially, if we were to try this, except instead we were to start from our second index, well, we'll find that it's true. Because starting from 2, it'll see that 2 is included starting from this part of the array onwards. But this is essentially how it works with includes when it comes to using what are called primitive types. Now, I'm going to explain what those are, but first I'm going to show you why this is important. If with our new array, let's say, for example, we wanted to find our second object with ID 2. If I do new array dot includes and then I try to find the object with ID 2, well, we'll get false. But why is that? Even though this object looks exactly like the element that does exist inside our array, why would we get false? Well, this is because of the way that JavaScript references objects versus primitive types. Now, what are primitive types? Well, let's actually look at this diagram here. In this diagram, imagine there's a memory bank, and this is internal to JavaScript. Inside this memory bank, JavaScript has a reference to every primitive type, and there are 6 of them. There are strings, strings being anything that we see between quotation marks. So this is a string, Boolean is true or false. Null is the null object. Undefined is also undefined, a unique primitive type. Numbers, so this is any integer, right? So that's any whole number. And also any float, so any decimal number. These are also all primitive types that fall under the category of number. And symbol, which is a bit more complicated, but it's essentially a unique thing. We don't really want to go too deeply into symbol because we're not really going to use it, but these are the 6 primitive types. And these primitive types all exist inside of JavaScript's memory bank. Now, when we set a constant or a variable equal to a primitive type, like say the number 3, what JavaScript is doing is it's creating this new variable that we want called a, and it's pointing its value to the number 3 in its memory. So it's actually pointing to 3 in memory. Now, when we set variable b to 3, it does the same thing. It creates this new variable called b, and then it also points to the same 3. Points to 3 in memory. If we set variable c to b, it's actually not pointing to our value of b. Instead, it points to b, which then points to our value in memory of 3. If we were to see this in action, let's say we did var b equals 3 and var c equals b. If we look at c, we'll see that the number is pointing to 3. If we changed b to 5, b is now pointing to the value in memory of 5, right? It's not really setting a value. We're saying that our value of b wants to point to the 5 that's in JavaScript's memory. But c is still pointing to 3. So c is not always going to equal whatever b becomes. C will only point to the value that b pointed to when we set it. Why was it that this didn't work? Well, inside of JavaScript, anything that's not a primitive type, so not any of these 6 types, is called an object. And an object is unique. Whenever an object gets instantiated, it gets its own unique reference in memory. Now, before we explore this, what is an object? Well, everything else in JavaScript that is not one of these 6 primitive types, as we mentioned, is an object, right? So arrays are also objects. And you can essentially just see objects as collections of things that have properties that have values. So my array, right, the arrays that we've created, they all have properties, right, because they have these methods on them. And methods are pretty much just properties that point to functions. That's why we're able to use them like functions. But we call them with the dot notation like it's a property on the object, right? And we're used to seeing objects as these curly braces with key value pairs inside them. Well, you can pretty much see that as everything else in JavaScript that is not one of those 6 primitive types that we're talking about. Now, whenever you see an object get instantiated for the first time, or for any time for that matter, what you're seeing is JavaScript store that object as a brand new reference in memory. So what do I mean by this? Well, let's say we made a new const object 1, which equals to this object with the ID of 1. This object gets a new reference in memory. Even if we were to make a new object 2, right? Let's say we were to point it to a different object, but it looked the exact same. This is actually going to be different. If we do object 1 equals object 2, it's going to give us false. Because what JavaScript is comparing, if the reference in memory is the same. It's not comparing whether or not this value of this object is equal to each other. It's comparing if they're both pointing to the same place in memory. This only works if we were to do something like we did earlier when we pointed our value of C to B. But instead, if we were to say, point our const obj3, right? So this new const, we want to point to object 2. Well, now we'll see that obj3 is pointing to this object. Now we can see that because both object 3 and object 2 are pointing to the same object in memory, if we do a comparison, we'll see that it's actually true because the reference in memory is the same. Now, the interesting thing about objects is that if we change the properties on them, if we add them or modify them, they'll always point to the same object reference in memory. So if I were to do object2.id equals 17, well, now object 2 is ID 17, but object 3, you'll see, still points to the same object in memory. So that would be how we would get our includes to work, is we would actually do const o1, right, equals a new object with ID of 1. Const o2 is equal to another object with ID of 2. Const o3 is equal to an object with ID of 3. And now we'll say const newest array is equal to o1, o2, and o3. So now if we were to display it, we'll see that inside our array is those 3 objects that we just made. And now if we do newest array dot includes and we were to point to, let's say, o1, we'll find that it's true because what we're referencing is that pointer in memory. So even though our array is this array, the elements inside are not new objects, but they're all pointing to the same elements in memory, which is why when we do the includes, the evaluation is true, because that's essentially what includes is doing under the hood. It's checking if the reference that we're passing in, right, is equal to any of the elements inside by their memory reference. So this is a bit of a longer lesson because we have to understand this very fundamental thing about objects and how JavaScript stores things in memory, but also how includes works when comparing and trying to find if an element exists in the array. We'll definitely explore these concepts a lot more as we code, and they'll definitely make more sense why the code we write is structured the way it is based on these rules.
In this video, we're going to talk about Git and GitHub and source control. Now, you might remember GitHub from our previous section where we used it to put the website online. But I'll show you that it is so much more than that. More importantly, Git and GitHub is used by most professional companies, and it is a skill that is expected to be known by all developers now. So this is an important section. One of the first things most developers have to do on their first day at the job is to submit something called a pull request, which uses Git and GitHub. We'll get through that in this section. Don't worry. You're going to learn all of this, and it's going to make sense. Let's first start with source control. Up until now, we have only worked on small files. No team members, just ourselves, just a couple of files. But in real life, you're most likely not the only developer on a team. Most likely the projects are huge. There's many, many files. Source control allows us to make sure that multiple people can work on the same file from different locations. Think of it as Google Docs that allows people to collaborate on one document. But enough talk, let's actually check it out. I have over here set up 2 folders. One is for myself, Andre, who just started a new job at X company. And I have Marcy here, who has been working at the company for a while, and she has project files over here. I'm actually using the files from our background generator video. Now, without Git or GitHub, what I can do is just copy and paste these files. So I have whatever Marcy has, and we can start working on these files. I can have my developer environment here with my terminal and my Sublime text, and I can work on whatever changes that need to be made on the app. And Marcy, over here, also has her own version where she can work on it. And we're both working on the same project. But let's say that both Marcy and I are working on this project, and she decides to change the project name from Gradient Background to Super Background. And at the same time, in my project, I decide to call this Cool Background. Well, now you'll have to set up a meeting between myself and Marcy and decide how we should change the code. And this is a small example, but you can imagine that as different programmers work together, there's always going to be this issue of one person changing one thing and another person changing another thing. This is where source control came in. And source control is a way to control this, where we have one place instead of our own computers. In this case, it's just represented by the folder that I have in here. Instead of each of us having a copy of the project, with source control, we have a copy of the project, but there is a centralized location up somewhere, maybe owned by the company or somewhere on the internet, that has the ultimate version that we each talk to make sure that we each have the same version. Git and GitHub is a way to do this, to be able to use source control. And as a matter of fact, it's the de facto way of doing this. So like I said before, this is most likely the tool you'll be using every single day at your workplace. So if I go to the GitHub website here, what it allows us to do is it's a place, a central place that both Andre and Marcy can talk to. So even though we work on the same files, the same project, I can ask this central location, such as GitHub, hey, has Marcy made any changes? And Marcy can ask, hey, has Andre made any changes? And every once in a while, you'll get something like this where we have cool background and super background, where we have something called a merge conflict. what GitHub allows us to do is say, hey, I noticed there's a merge conflict. I see that you guys have both changed your background. I don't know who's right, but here's the information. Andre and Marcy, can you guys talk amongst yourself and figure it out? That's pretty much the workflow. So let's actually see what this looks like. The first thing we want to do is set up a GitHub account. If you haven't done it in the previous exercises, you absolutely should start a GitHub account. It's free. And like I said before, if you're a developer, you just need to have it. It's where everybody puts their projects. It's where you work. You'll be spending a lot of time on this website. You might remember that when we had the GitHub project, I also told you to get GitHub for desktop. Although we used that to make things simpler during that video, this is actually not the recommended way of doing it. It allows you to visually see and interact with GitHub, but it's kind of looked down upon by employers, and most people use the terminal or the command prompt to actually do this. So I won't be teaching you this way just because I think it's bad practice and getting used to the terminal is important. I'm going to close that and we're going to get this started. The very first thing we're going to do is we're going to click on Start a Project. And here we're going to call it whatever we want. We'll call it Background Generator. And you also want to leave it as public, and we want to click on Initialize this with a README. And we'll click Create Repository. And what that does, well, we've created a new project on GitHub. And here, the README, which is just a file that describes your project, you can see that it's here. We can type into the README whatever we want and it'll describe our project. But let's go back. If Marcy, let's say Marcy has been working at this company for a long time. I'm actually going to remove my files here. Marcy has been working at this company for a long time, and the employer finally decided, hey, we need to use GitHub. We're going to hire this new guy, Andre. We want to make sure that you both can work on it, on the project together without any issues. Can you put the project up on GitHub? So what Marcy will do is she will go to GitHub, create background generator, and then she's going to click right over here to clone or download. And she's going to make sure it says use HTTPS. And from here, you just click on this button, which copies this link to your keyboard. Then Marcy goes to her terminal. And right now we're in Documents. We want to have the project in the Marcy folder. So I'll cd into Marcy. If I click ls, I see that, yep, I have my files. Now, the first command that we're going to learn is called git clone, and then copy and paste what we copied from the website. We're just saying, hey, clone this project from github.com. So I press enter, and there you go. Everything is downloaded. If I go back to the folder now, I see that I have background generator. If I double click this, you'll see that I have a .git folder here that's actually hidden. You might not even see it on your laptop if you don't have this feature on your computer enabled. But this .git now allows me to communicate with GitHub. So what we can do now, Marcy can copy and paste these files and put it into background generator. Now let me show you the next git command. Marcy right now, if we see, she's in her folder, but now we need to go into background generator, because if we do any git commands here, well, it won't work because it's not a git project. We need to actually go inside of the project that was created on GitHub. So I'm going to cd into that directory. Notice here, I have my terminal set so that it actually shows me what GitHub location I'm in, and I'll explain what master means later. Now that we're here, we can look at all our files. Yep, I see that now I have my README, which I created on GitHub, plus the files that I copy and pasted. We need to sync this so that if I go into my background generator, instead of the README files, Marcy can put up her files on GitHub. The way we do that is our second command, git status. It tells us that we have untracked files. That is, we have index.html, script.js, and style that are untracked. And it says use git add file to include what will be committed. So now that we see our status of what we have in our folder, we can say git add and the file name. So I can do index.html, git add script.js, and git add style.css. Let's clear this so we can see it. And now I can do git status again just to see what our status is. And now I have your branch is up to date, changes to be committed. You see that now with add, we've said, hey, we want to add these changes. We have new files that we've added and says to be committed. So the second step is to do something called git commit. And git commit says, hey, I'm committing that these are the changes that I want to make to GitHub. And it allows you to pass a message so that on GitHub, it'll show the message. When Andre comes back in, he can say, oh, Marcy added these files and this is the message. And we do that by doing this. And within here, within the double quotes, I can say adding, starting project. Close the bracket, press enter. I'm going to clear this. Now there's one last step. We did git add to add our changes, then git commit to commit and say, yeah, we're locking in those changes. And then finally, we need to let github.com know that these are the changes. So we do git push. And there you go. It has now been pushed to this repository. So if I go back and I refresh, look at that. It's the same thing that we did when we put up our first website online, but instead of using the desktop version of GitHub, we use the command line. And now we have our project, which is very good. Now let's go back to our example. So Marcy has been working on this project. There's a Git repository, and I just joined the company, and now I need to start working on this. What do I do? Now I need to access GitHub and get the copy of background generator. The way I do that, well, I go into my folder and I do the same thing. I do git clone and then I copy and paste the repository just like before. Git clone and clone the repo. And there you go. If I go back to my folder, look at that. I have background generator. So we're both working now on background generator, but not off of each other's files. We're working with whatever version is on GitHub. All right, so now more realistic. We go back to working, and on the first day of my job, I say, I'm going to change the gradient background title, actually the H1 tag, to cool generator. If I save this and I do git status, well, I'm not in a Git repository right now. If you remember, I have to go into background generator. Let me open that up a bit so you can see. There you go. Again, these Git commands won't work if you're not in a folder that has the .git folder. So let me do that. cd into background generator. I'm going to clear this and I'm going to say git status. And look at that. It tells me that I've modified index.html file. And if we remember, I will say git add. I only have one file. I can do index.html. But if I had multiple files and I want to just commit all of them at once, I can just do the period. So I'll do that and then git commit and I'll add a message changing title. I press enter. I'm going to clear this. Okay, and again, I do git push. And it looks like everything went through. So let's open that up and check it out. I now refresh here. And, well, we haven't seen any changes, but we now see that we have 3 commits. We have the initial commit, the adding background project that Marcy did, and it shows you all the files that were added. And if I go back, I have the changing title commit. And now I see that, yeah, Andre just changed the background generator, which is in red, to cool generator. So as you can see, we have a history of all the changes, and we can always go back if there's any mistakes. But there's one issue right now. If I go back to the code and I go to Marcy's computer, I see that, well, she still has background generator here. Why is that? Well, because her computer doesn't know that GitHub has been updated. The next command I'm going to show you, this is the last one I'm going to show you in this video, is git pull. So remember, git push to push the changes to github.com, and git pull to pull whatever's the latest. So I do git pull, and there you go. You see over here that it shows me that index.html file was changed. Now you see that my title has been changed to cool generator. Let's just say that Marcy saw my first change and she really likes how I've added cool generator, but I think she wants to make it capitalized. Again, she's going to save that. She's going to say git status. All right, I have my index.html file, git add, then git commit, and I'll have the message capitalize title, and then git push. There you go. Again, I go back, I refresh, and now there's 4 commits, and we see that capitalized title is the new changes. The first day of work is done. I come into the next day of work, and well, I want to start with whatever the latest project is of background generator. And let's say Marcy worked all night to change that title to cool capitalized. I want to make sure that I have the most updated version. So what I do is when I get into work in the morning, I'll say, well, I want to make sure that if there's any changes that Marcy made, I know about them. So I'm going to say git pull, and notice here how the title's going to change after I do the pull. And now I click to Sublime Text, and there you go, cool generator. All right, in the next video, we're going to expand on this and show you what happens if both Marcy and Andre make the same changes. What does GitHub do? I'll see you in that one. Bye-bye. Welcome back. Let's continue from our previous video to talk about a more advanced workflow in Git and GitHub. Now, up to this point, both Marcy and I have just been working on, over here, branch master. What does that mean? Well, it says branches, but I only see master here. And you might have noticed one issue with the way that we were doing things. That is, if it's my first day on the job and I just changed the title, but maybe we didn't even want that change. Maybe that breaks our branding or breaks our app. But I was able to do it so easily to change it into master. Maybe Marcy didn't even know that I've added that change. And that's a big problem, right? You don't want to put things into what we call production, into what the user sees, if it's going to break our website. If you're a big company like Facebook, that could mean millions of dollars in lost revenue, even if you have a bug that lasts a few hours. So I'm going to show you a more realistic workflow that you'll have, and that is with branching. Let me show you what I mean. I have over here a visual of what Git is really good at. Up until now, we've been working on what we call master. That is the master branch. Think of the master branch as the authority. This is the right way that our app or our website should look. And up until now, when I added the cool background title, well, I went from background generator to cool generator. And then when Marcy changed it to capitalized letters, then we went to here. And we just went in a linear fashion from one end to the other, to the other, to the other. But like I said, that is a bit of a problem. So a better thing to do is what we call branching. If I wanted to change the title, I will create a branch and just call it little feature, for example. And I just work on that branch on my own without affecting the master branch, what the user sees. And only when it's finished, when Marcy has reviewed it, when we have tested it and everybody on the team's okay, then we bring it back into master. And you can see over here with the big feature, you can keep going for a long time on your own branch. And only when you're done, do what we call merge into master. I'm going to show you how that works today. I'm going to close this and remember our example. We have Marcy's computer here with all the files, and we have my computer here with all the files. We both have our workstation set up. And now you see what master in my terminal means. And I'll show you in the notes afterwards how you can have this set up so it tells you what branch you're on. But we can see that we're both on master. That's my computer. And Marcy's computer is also on master. We want to make sure that we're both up to date with the latest GitHub. So Marcy's going to do git pull, and I'm also going to do git pull. And let's say that I'm now working on a new feature. And because it's a better workflow not to work on master, and this is a good tip generally, don't work on master, always branch off. If I do git branch, it'll show me that, well, I only have one branch, and that is master. But we can add to it. We can say git branch new or little feature. And now if I do git branch, I see that I have little feature, but master is highlighted because I'm currently on master. So the way I would go to the little feature branch, I'll say git checkout little feature. And there you go, switch to branch little feature. And now I'm on little feature branch. So what I've done is I've branched off of master and now created little feature. Let's create a bit of a change. I'm going to say in the little feature, we're going to change the current CSS background title to say, this is the background. I'm going to save here. And again, I do my simple workflow that we did in the last video. Git status. I see that, yep, we have the index.html change. Going to clear so we can see. So now that we've made this change, let's do git add. And again, just git status to make sure everything went through. Yeah, we're ready to commit index.html. So we'll do git commit. Message will be changing text. Perfect. Let's clear that. And now, again, in order to let GitHub know of the changes, we need to do git push. So we'll do git push. All right. Let's go to GitHub and see what happened. We see that now we have this yellow bar that just showed up and says you recently pushed branches. So if I click on this green button here, compare pull request, it shows me what changes I have, which is I've changed the title. And here I can let Marcy know, saying, Marcy, I've changed the text. What do you think? And I click on create pull request. And now I have my PR. And you see here how it says merge pull request. Well, if we go back to our diagram, I've created this little feature. And now I'm saying, hey, Marcy, I've just done this new change. What do you think? Is it okay for me to merge it into master? And what will happen here most likely is Marcy will come, see this pull request. You can see that we're on the pull request tabs. So she'll be able to see them and seeing, oh, Andre just did this change. She'll look through the changes and she'll say, well, If she likes this, she could be like, looks good. She can click on Start a Review. And you know what? She likes this, so she's just going to approve. Now, Marcy or myself, usually you don't want to merge your own pull request. Somebody on the team does it. Can now just say merge pull request. Confirm merge. And there you go. Some teams like deleting the branch afterwards, so you can just click delete here. If I go back to the code, well, I don't have the branches anymore because I just deleted it. But in my master, if I go to index.html, I see this is the background. So now Marcy can go to her project and say git pull. And again, she has the latest update. Now let's talk about some conflicts that can arise. Now let's say Marcy wants to change something, and I also change the same thing, and we get a merge conflict. Let's see what happens. So let's say Marcy wants to create a new feature saying, we'll call this one big feature. And she'll say git checkout or git branch big feature. She'll say git checkout big feature. And if I do git branch, we see that, yep, there's a new branch here. Let's clear that. And she'll say here that she wants to change this back to background color or background generator because all the users are complaining that the title changed and they like the old title. So she's changed that. She has done the git add, git commit, reverting back to old title. Perfect. And then she's going to do git push. Oh, let's clear that first actually. And we do git push. The first time you get this, you might get this error saying that there's no upstream. You just copy the code that they give you here. Perfect. Now if I go back to background generator, I see the big feature pull request over here. And just to show you that you can have multiple commits, let's say Marcy decides to, oh, this is me. Marcy decides to add an exclamation point here. She can just say again, she saves this. That's clear. She'll say git add, git commit. You do this a lot, so you'll get really, really good at Git after working at a company for a while. And she'll say added exclamation. Oops. That's not what I wanted to do. Git commit. Commit. Added exclamation. And she'll do git push again. And let's go back to GitHub. If we look at the pull request, it'll actually have both of these, reverting back to old title and added exclamation. And we see over here both of the changes. Create the pull request, needs changes, Andre. So while this pull request is out there, I decided to start a new branch called, let's just call it conflict for now. And I'll do git checkout conflict. And now in the conflict branch, I decide to change this to just completely remove the cool generator. I save that. Again, I check my status and index.html file has been changed. So while this is happening, I get Marcy to merge the pull request. So she's entered it into master. Her pull request is in. And now if I go back to my conflict and I do git status, and we have to add these, so git add, then git commit. I'll just do a short message here, just check. And now, if I go back to master, Oh, I have to do git checkout master. Again, before I push my changes, I want to make sure that I have the latest version of master, so I'm not changing anything, or I won't have any conflicts. So I'll do git pull to get the latest. And now I go to git checkout conflict branch. And I can do this command, git merge master. So I'm saying merge whatever is in master into conflict. Marcy has been working on the big feature and she's merged it. So now master has the big feature branch. But I've also created another branch and I've been working on my own on the conflict branch. And the conflict branch doesn't know anything about master. So I'm saying, hey, whatever's in master right now, which includes the big feature that Marcy worked on, pull it in and make sure that there's no conflicts. So I do that, and I get conflict, merge conflict in index.html file. Now, if I actually click on Sublime Text, let me open this up so you can see it better. Oh boy, I get this weird little syntax. It's overwhelming at first, but it's easy to see what's happening. Head is where my branch is at, and it shows me that here to the end, I don't have the H1 anymore, but in the master branch, we have background generator. Now I can talk to Marcy and say, hey, Marcy, do you want to keep the background generator title? And she'll say, yes, that was the right thing to do. Don't change the background. Well, in that case, I just remove these lines and remove this and save now. If I do git status now, okay, we have the modify status here. Let me just make this smaller again so you can see. So let me clear this. What we do now is we have to do git add, again, because we made those changes. And we have to do git commit fixing merge issue. And I forgot the M. Let's try that again. M conflict fixing merge issue. Let's clear here and do git status. Nothing to commit, working tree clean. And if I do git push, well, again, I get this error, but I want to show you this time around. If I do git push origin conflict, it now works. Let's go back to GitHub. See what sort of things we have. We have the conflict branch. And if we look at the conflict branch now, well, there's nothing changed because, well, I just reverted all my changes. So it's completely empty. There's no changes now. So Marcy will be like, hey, did you mean to make this PR? It's empty. So I'll see this message on my PR and I can keep going. And that's pretty much the workflow that you'll see in Git. I'll leave the commands for you after this. But you see, it's very, very nice to work with. You learn a few commands, and as long as you have this visual model of every time you're working on something, you always create a branch. You title it with whatever feature you're working on. And every once in a while, you want to pull master and merge master into your branch to make sure that you're not missing out on any updates that other developers or teammates have done. Once you're done with your feature, you make a pull request by doing git push. And that pull request, you'll add comments and people will review your file changes. And if they want you to make a few changes, then you can do again git add, git commit, finally make your changes, and then you can merge pull request. And once that's done, then everybody else on the team, there's now a new master. So everybody else on the team should do git pull as well. It does take a bit of time to get used to, but it's a really, really nice workflow to make sure that everybody on the team works on the same files, same projects without causing any errors and making sure that everybody collaborates well. And that's it. Hope you found this useful. I'll see you in the next one. Bye-bye.
Okay, async await. This is one of the most exciting features that developers have been waiting for. It is a way to write functions that contain promise-oriented or asynchronous code that looks synchronous. So, what do I mean by this? Well, when we think back on our last lesson on promises and fetch, we know that with our fetch call, if we were to write it with the style of promises, that we would fetch our users, and then we would get the response. We would call response.json, which gives us back a promise, which we then pass to our then, which now finally has our array of users. We would then cast our first user constant with the first user object in our array. We log it out so we see what our first user looks like. And then we return fetch to this link, right, which has posts, except we set a URL parameter where the user ID is equal to our first user.id. So we want all of the posts related to our first user. And then we get back a response. We convert it to JSON again, right, which then we pass through into our next then, and then we console log the final posts. So it's a lot of things happening here. And what this actually looks like for us, if we copy this, we go back to our browser, and then we paste this in, we see that what we get is our first user, which gets logged, and then we log our final posts, right? So this is pretty much stuff that we're familiar with when it came down to writing our code. Now, if we wanted to do this in async await, the way that we would do it is we would cast a function called myAsyncFunction, right? And we make it an async function by writing the async keyword. And then we essentially write a function anyway after, right? So by saying async and then our function declaration, JavaScript knows that we want to make an async function. Now, by using this async keyword, within our async function, we're now suddenly allowed to use the await keyword. And what await does is it pauses the function's execution until what is being awaited is completed and comes back with a value. So what do I mean by this? Well, if we were to say await and then we want to fetch this value that we had above here, any code down here would wait until this fetch comes back with a value. And the way that we would use that value is we're actually able to cast it to a constant because that's what await does for us. Await takes that resolve promise value and then sets it to the constant we declare it equal to. So if I say, this is my user's response, right? Now I have that same response object cast to this const user. And any code following was waiting until this fetch completed. Now we do this again with our actual users, but we have to await for our user's response to be converted to JSON, because this is also an asynchronous method of converting it to JSON. So this method returns as a promise, right, which resolves with the final JSON value of our users, which we cast to our const users. And now we can say const first user equals users at 0, right? Let's console log this first user as well. Actually, let's just change it up, and instead of our first user, we'll say second user, right? So we'll use our second user. And then we want our posts response equals to our fetch, right? Like so. Except we want to use our new second user. But our fetch, we want to await for it. And then we want our posts to be await of our posts response.json. And now finally, we console log our posts. By doing this, this code reads more like synchronous code because we see, oh, there's just a variable declaration. It's just waiting for our asynchronous requests to complete, and then they cast their values, right? Their resolve promise values to our consts respectively. So as we see, this actually looks a lot like normal synchronous code that we would write. Now let's see if this works. So let's copy this. And then let's just paste it in. And let's call my async function. And we see there's our second user, and there's our posts related to our second user. So this is what async await allows us to do. So both methods are valid when it comes to tackling this kind of asynchronous problem. Specifically, what we were trying to solve was that we had code that was dependent on an asynchronous code above it, right, to complete before it could actually run. What do I mean? Well, we were not able to fetch our second user's posts without having a second user in the first place. And getting our second user was dependent on fetching a list of users first, right? This code is asynchronous. We did not know when that would complete. This could have taken half a second or it could have taken 3 seconds, depending on multiple factors. Now, both are valid because this structure of promise chaining is just like await. Each then is waiting for the previous one's then callback to complete. So this return of this promise, this whole chain is waiting for this then block to complete and this fetch to complete, resolve or reject. But with async await, we're able to write it in such a way that it resembles more of the synchronous code that we're used to writing, because we're able to cast these constants, right, which are just equal to awaited values of these function method calls. So in a way, you can do both. It doesn't matter. It's just which one is more readable, which one is more reusable. Now, one thing I have not yet talked about with async await is error handling. We know with our promise chain that if we do a .catch right here, we are able to handle our errors. If an error occurs at any of these thens, this catch will catch the error for all of them, right? If any of these reject, this catch will be there for it. How do we do that with an async await function? Well, what we have to do is use a JavaScript try catch block. And what that looks like is just this. We have a try keyword with a block of code, and then there's a catch keyword with our error, and then a second block. So we put the code that we want to run inside of our try block. And then in the catch, if any error occurs in this try block, any promises reject, any of the stuff with our fetch that fails, right? Then this catch code will run, and that error is what will get passed in here. So if we wanted to console log, there was an error, we are able to handle our errors this way. So if we were to try this, and let's say we just mistype this string, right? Now if I call my function, we will see that our error got thrown. So while this code ran, it's because up until this point, this code was all valid. But the moment that this error occurred at this fetch, it threw the error, it paused the execution, right? It doesn't keep going, and then it just throws. So this is how async await works. And just like that, you now know the 2 ways of handling asynchronous events. Now, before we do reduce, let's do find. So what is find? Well, let's first get our array again. So we'll just copy over what we had from our last experiment. And find is also exactly as it sounds. We're trying to find an element that correctly returns true based on the conditional that we have and the return of our function. Very similar to filter. So what we would say is myArray.find, and we would get our element. And let's say I wanted the element that is equal to 5. Well, here it would get us our element, 5, right? Because if 1 goes in, is it equal to 5? No. 3? No. But 5 is true, and the moment that it's correct, this method actually stops, and it gives us back the first value in the array that returned true from calling this function on each element. So it won't keep going. So a way we can actually see this is if we say myArray.find, and we get our element. And let's say we do as long as the element is greater than 4. So theoretically, 5, 7, and 9 are all true. But because it's applying it from left to right on each element, the first element that this returns true, it will return, and it won't keep going. And we know that it will be 5. So .find is a great way for us when let's say we have an array of objects, right? And we want to find a specific object based on some condition, right? You can imagine if we had, let's say, people array, where we had an array of objects where the ID was 1, the ID of 4, and then the ID of 7. If we wanted to find people array, right, with the ID of 4, well, then we would say person, where person.id was equal to 4. And now this will give us our second item, where it's our person with our ID of 4. So this is the great thing about find, is that find will give us the reference to whatever element it is that matches the condition that we pass in the function of our find. And we will use this as well quite extensively in our coding. Let's talk about reduce. Now, reduce is probably the trickiest of all array methods. So it's okay if it seems really overwhelming as we're going through it. But I promise you that once it clicks, it will make total sense. And it's actually one of the most useful array methods that we have in our repertoire as JavaScript developers. So in order to understand it, let's go into our browser. Let's say I had some array which was equal to 1, 2, 3, 4, 5. Now, let's say I wanted to add all the values inside of my array. How would I do this? Well, we could write a for loop, right, where we add all the values together and end up with some final value. Or this is actually the perfect time to use reduce. Reduce is a great array method to use when we want to do two things. The first is that we want to end up with one value in the end, right? Not an array, but some value in the end. The second is when we want to persist the return or the outcome of iterating over our elements in each subsequent iteration. Now, what do I mean by that? That's a mouthful, right? Well, let's take a look at how the code actually looks, and then maybe it'll be better for us to understand. Let's say I call array.reduce. Array.reduce takes two arguments. The last argument we won't focus on for now. Let's just focus on the first argument. The first argument is a function, and that function has two parameters. The second parameter is the element itself. So it's the current element that we're on, that we're iterating over. The first one is what's called the accumulator, right? The accumulator is exactly as it sounds. It's the accumulated value of calling this function on every element before the one that we're currently on. So what we would do if we wanted to add all these numbers together is if we said accumulator plus our current element. And what we would pass to our second argument is 0. Now, you might be wondering, well, what's the first value that accumulator has when we start at the first element? Well, that's actually what this second argument is. And that's why we pass it 0, because we want to add all of these values together. We want to start from 0. And if we call this, I think I have an extra bracket by accident, we will get 15. Now, let's walk through how this works. So the first time this function gets called, accumulator is 0, right? And 1 is the current element. So it'll be 0 plus 1, right? Which gives us a value of 1. Then it moves on to the next element. And here, accumulator will get the return of our last function call on this element, which is 1. So accumulator is 1, current element is 2, and we'll get 1 plus 2, which equals 3, right? So 3 gets passed as the accumulator in the next element when this function is called, and we'll get 3 for accumulator and 3 for current element. So we get 3 plus 3, which is 6, which then gets passed as the accumulator for the next element, which is 4. So accumulator of 6, current element of 4, 6 plus 4 equals 10, and then finally one more time on 5, where 10 is the accumulator, the current element is 5, and that's how we end up with a value of 15. And this is how the reduce function works. Now, you don't necessarily have to start with 0, right? We only did this because the purpose of what we were trying to achieve was to add all the values together, right, in our array. But if we wanted, all this second argument symbolizes is the first accumulator value when we get called on the first element. So if I said that this was 10, what happens is that 10 gets passed as the accumulator when this function first gets called on 1. So it's 10, current element is 1, 10 plus 1 is 11, which gets then passed as the accumulator when we call it on 2, right? 11, current element is 2, 11 plus 2, 13, and so on and so forth for each subsequent element until we end up with 25. So this is how we write reduce. Now, there's a lot more complicated ways that we can use reduce, but the basics, the fundamentals of how reduce works is in what we just wrote. Now, it's okay if you don't grab it all right away. It's a lot, and it's always one of the trickier parts of understanding this specific array method. Now, we will definitely encounter more opportunities to use reduce throughout our course. But right now, I want you to just maybe play around with some of this array that we already have, right? Play around with some of the numbers so that you get a familiar feel for it. But in the future, when we encounter opportunities to use reduce, we'll definitely slow down and take a look at how we're writing our code so we can better understand how to write reduce and when it's actually a good solution. But understanding reduce and knowing when to use it will be a very powerful tool in our careers as JavaScript developers.
Let's talk about currying. Now, currying is the technique of translating the evaluation of a function that takes multiple arguments into evaluating a sequence of functions, each with a single argument. That sounds pretty confusing, doesn't it? Well, you can think of currying like this. You take a function that can take multiple parameters, and instead, using currying, modify it to a function that takes one parameter at a time. Let's have a look at an example. I can create a function, multiply. And this multiply takes a and b as parameters, and we're just going to multiply a and b. If I do multiply 3 times 4, I should get 12. Nice and easy. How can we use currying here? Well, remember, we want to change the function from taking multiple parameters to taking a parameter at a time. We can do something like this. I can say const curried multiply, and we're going to take a parameter, which is going to return another function that takes another parameter. And that is going to multiply a times b. Because of closures, we have access inside of the b function to the a variable. Oh, and make sure I say const here. There you go. Now, how can we use this? Well, I can now say curried multiply 4, or let's do 5 times 3. If I run this, well, no, that doesn't work. Remember, because this is curried. It takes one parameter at a time. So instead, I'm going to do curried 5, which is going to give us the first variable. And the way that I like to look at arrow functions is that I can mimic how the function is written in the way that I call the function. So I see 2 brackets here with a and b, so I can call it with a and b. So if I do 3 here and run, there you go. I get 15. So I'm giving the function one parameter at a time. But why is this useful? I can now create multiple utility functions out of this. For example, I can say const curried multiply by 5, which is going to equal this curried multiply with the parameter of 5. So that now I've called this function once, and this function for the rest of its time, or at least this function, is going to remember this piece of data 5 for, well, forever, until we finish running the program. So that, let's say 10 years from now, we finally remember, oh, we have this curried multiply by 5 function. I can use the multiply by 5 function and multiply anything that we want by 5. Let's say 4. If I run this, I get 20. And instead of running this function over and over, I've run it once, and now this curried multiply by 5 is there for us to use. So if it's a function that gets called many times, we only run this part of the function once, which is really, really cool. And currying almost reminds you of those methods, right, on prototypes that were shared amongst objects. They're trying to save on memory, or at least the amount that our computers has to work. Now that we have seen currying, let's go to the next topic that gets often confused with currying. I'll see you in the next one. Bye-bye. All right, we've gone closer and closer. Let's reach ultimate object-oriented programming in JavaScript. We have our constructor functions that, well, were a little funny. Nobody really liked the prototype ways of adding methods. So with ES6, JavaScript finally got the class keyword. Object-oriented programming was created with the class idea in mind, a class being a blueprint of what we want created. Let's see how this works. With the new ES6 classes, we can now do this. We have the elf class that we just simply define like that. And then we have a constructor. And then the constructor is something that gets run every time we instantiate or use the new keyword on a class. So this goes inside over here, and we take in the name and weapon parameter. Now, the beauty with classes is that, as object-oriented programming suggests, we want to keep all our functionality inside of this box. All the properties, all the state, all the methods, all the actions together in a nice contained environment, a class, an object. So instead of having these in a separate location, I can now just simply add attack in here as part of our class, and this method can now act upon our state. So I can just return right here. And I can get rid of this ugly prototype. How nice and easy was that? Let's see if this works. If I click run, look at that. It's all working. How much cleaner is that? And if you're coming from an object-oriented programming language like Java or C++, this is going to look really familiar to you. And this is the true beauty of object-oriented programming. We're modeling real-life scenarios. We're creating an elf class that is a blueprint of what we want elves to be like. Well, elves have names, they have weapons, and they can act upon these properties like attack or build. And we can just keep adding things here. And we have one location that holds this entire elf object. And anytime we need to update something or change or add a method, we can just change it in here, and all the instances of the elf will get that update. Now, I keep saying this word instance, and this is a common term that you'll hear a lot when it comes to object-oriented programming and when we use classes. An instance happens when we call this class and create an object out of this class. So for example, Peter is an instance of elf. For example, if I do console.log and do Peter, and luckily for us, JavaScript has instance of, then do elf. If I click run here, I get true. Peter is an instance of elf. So is Sam. But if I do elf instance of Peter, I'll get false. Because, well, it's the other way around. So instance of is this language that we can use in object-oriented programming to say, we're creating an instance of a class. This, with the new keyword, is called instantiation. We're instantiating a class. If I remove the keyword from here, the new keyword, and I click run, I see that class constructor elf cannot be invoked without new. We even get a nice error saying, hey, we need new here. Don't forget new, which is really, really nice. All right, everybody, cheers, get up, throw your chairs, throw your laptops. All right, don't throw your laptops. But we finally have classes. We finally have object-oriented programming in JavaScript, right? Well, not really. You see, this is what we call syntactic sugar. Underneath the hood in JavaScript, we're still using prototypal inheritance. We're not using classes like classes work in other languages. This is the closest that JavaScript is going to get to classes. Underneath the hood, they're still using the new keyword with the prototype. And you're thinking to yourself, whoa, why didn't we just, all this trouble, why didn't we just create classes from the beginning in JavaScript? Wouldn't it just make everything easier? Now, as we'll find out, classes aren't necessarily the answer to everything, as we'll see when we get to functional programming. But also, there's an interesting story or quote behind why JavaScript doesn't have classes. This is a quote from the creator, Brendan Eich of JavaScript. If I had done classes in JavaScript back in 1995, I'd have been told that it was too much like Java, or that JavaScript was competing with Java. And I was under the marketing orders to make it look like Java, but not make it too big for its britches. So the interesting thing was that Brendan Eich was tasked with creating a language that would attract Java developers that were really used to classes and object-oriented programming concepts. But at the same time, they wanted to create a competing language. And for marketing purposes, they couldn't make it the exact same. So he had to be creative. So he used prototypal inheritance, which is quite different from how classes work in languages like Java and C++. In other languages, classes are an actual thing. In JavaScript, classes are still just objects. Everything in JavaScript is an object. So in an interview, if you get asked, hey, does JavaScript have classes? Well, yes, they do, as syntactic sugar, but class keyword is still just prototypal inheritance. And some people call this pseudo-classical inheritance because it's not real classical inheritance. Looking at this, I hope you see how we've gone from repetitive code that was harder and harder to maintain to something that's a little bit more organized. We've created this grouping of functionality so that it's easier to maintain and extend. By the way, you may be asking yourself, why don't we just add a tag to the constructor? Why do we just put it outside over here? And this is actually a very interesting question that you might get in an interview. You see, every time we use the new keyword and create or instantiate a class, the constructor function gets run, because this constructor function needs to get run because each elf has a unique name and perhaps a unique weapon. But attack is shared by all instances of the class. If we moved attack to the constructor, that's going to take up memory space, right? Instead of creating an attack function from each object, which is what we would do if we added to the constructor, and that's something that we've been trying to avoid, instead we just have one function in one location that all these instances can access. So there you have it. I hope you start to see the beauty in efficiency. Let's take a break and talk a little bit more about this in the next video. I'll see you in that one. Bye-bye. Welcome back. Let's talk about inheritance. A core aspect of object-oriented programming is inheritance, which means passing knowledge down. Remember, at the start of this journey, we decided that we want to create this game, this fairy tale game that had all these characters. And we started with elves, just a couple of elves. But as you can see, our goal is to have many things. We want to have maybe a dragon, a knight, a king and queen, maybe some magicians, yes, even Dracula. So using this object-oriented programming principle of inheritance, how can we accomplish this with the work that we've already done? Let's have a look. We have our elf class here. Yes, we've seen it before, and it shouldn't be anything new. But let's say that I wanted to have a new player, and this player is actually an ogre called Shrek. How would I go about creating this ogre? The one thing I could do is to copy and paste this code and create an ogre class. I mean, that's copy and pasting dry code that eventually we want to avoid, because as we keep copying and pasting, we just have repeated code, which gets messy. So one option that we might have here is, well, let's just copy the elf and maybe we can extend it. So for example, if I want to copy Fiona, let's say Fiona over here, if I click run, I have this elf class or elf instance with all these properties. Now, in order to copy what we already have, we can just do something like this. We can say const ogre, and ogre is going to equal, well, let's clone Fiona. And as I've shown you before, we can do ... spread operator, and then just do Fiona. If I do this, let's remove the spaces, and I look at what ogre is now, and I click run. Look at that. I've copied Fiona into the ogre variable. And the interesting thing here is if I do ogre dot underscore underscore proto underscore underscore, what do I get? I get an empty object. What if I do Fiona? I have elf. So I've cloned the object, but ogre no longer has elf as the class, the base class. So that if I do here console.log Fiona equals ogre clone, and I click run. Oh, and I don't need the clone here. It should just be ogre. I get false. These objects are not referencing the same place in memory. They're completely different things. But I've also lost this chain, this prototypal inheritance chain. I can't even do ogre.attack. Nope, I don't have attack. So that's a problem. How can we extend this work that we've currently had? And this is where inheritance comes in. And it used to be really difficult to do with JavaScript before we had this class syntax. It involved a lot of ugly prototype code that, luckily for us, is now a lot cleaner. So let's have a look. To start off, to make naming a lot better, I'm going to change the class here to character, because all characters in this game are going to have name and a weapon, and they can attack. That's great. And now from this character, I'm going to create a class elf that extends, which is a keyword, this character class. This is something called subclassing in object-oriented programming. That is, we have a base class or a superclass and a subclass. That is, we want to inherit from the character class all these properties and methods and create something new out of it, extend it with elf. Let's have a look. If I just do this and I click run, all right, I get undefined. Let's see what Fiona is right now. If I do Fiona and click run, all right, look at that. Everything is still working. I have elf, name Fiona, weapons ninja. All right, great. But you know what? Let's make this a little bit more interesting. Let's say that the elf characters in this game, they also have an extra property that they can have. Maybe it's a type property as to what type of elf they are. So let's build that out. How would we go about doing that? Well, in here, let's add the type property. If I do a constructor in here, and I do this dot name or this dot type equals type, and let's say that we receive a type parameter in here. How is this going to work? We have to instantiate the elf class, and we give it the name and the weapon, but we also want to have the type. So maybe we'll do this. We'll say name and weapon, and the third parameter will be type. So I'll say that type of this elf, I'm going to change the name from Fiona to Dobie. The name is going to be Dobie, and the attack is going to be, well, or the weapon is just going to be a cloth, and the type of elf it's going to be a house elf. All right. If I do this, let's see what happens. I'm going to click run. Reference error. Must call super constructor and derived class before accessing this or returning from derived constructor. Does that make sense? Not really, right? I mean, that's a pretty confusing error message. What is it saying? In order for us to have our constructor and be able to use this and know what this is referring to, which is elf and not the character, because remember we have both name and weapon, we have this special keyword called super for superclass. And this superclass we call like this. And by doing inside of the constructor, the super call, it says, hey, call the superclass. What's the superclass of elf? Well, that's character. It extends character. So it goes up and calls the constructor so that we create this.name and this.weapon. So in here, we have to pass it name and weapon. Now I know this is a little bit confusing, this whole super thing. It's just a standard, especially with classic class-based languages, where super is referring to the superclass. Let's have a look here. If I click run, look at that. I got elf, that is Dobie, weapon is a cloth, and has a type, well, it's a house elf. And if I do Dobie.attack, attack with cloth. Not very effective, but it's working. Now, let's go over this one more time. When we do class elf extends character, it means, hey, extend and set the prototype, that is the __ proto, to point to character. So elf now has a prototype chain up to character. It's saying, hey, anytime you run an instance of elf, like Dobie, and it uses a property or a method that I don't have, well, then look up to character and tell me if character has it. The constructor is our own constructor just for the elf class. This is something that only gets run with an elf, not with a character. And in here, we can leave it as is. But if we want to set any sort of property that is use the this keyword, we have to call super and say, hey, call the constructor of our superclass. And then after that, I'll know what to do with this keyword. Let me show you. If I do console.log here and do this, and I run, that gives an error. Because in order for us to use the this keyword inside of the constructor, when we extend something, we have to call super first. So that if I move the console.log to under the super call, and I run, look at that. I have elf that has name and weapon attached to it. So this, because we call the super, runs the constructor. We now have a instance of character with these properties, and then we can use this.type to add type to it, so that by the very end of our construction process of elf, we have all our properties set. Very, very cool. And remember, the this keyword simply says, who am I? Who's calling me? In this case, we use the new keyword, so this is going to be set to elf. All right, but we started this video with us wanting to create an ogre. So let's do that. Let's continue on. Let's create another class that's going to be an ogre class that extends the character. We do the same thing now. Let's say that our ogre has a constructor, and we want to pass in a few things, such as name, weapon, and you know what? Ogres have different colors. So let's do that. Let's add a color property. And what do we do here? Well, we're going to call the super class, which is character, with name and weapon. So that now we can use this keyword to attach new properties to the ogre class. I'm going to add a color that equals whatever color we give it. And you know what? Ogres, they have special powers. Let's say that ogres can also make forts. So we have a make fort because, they're very powerful, obviously. And they'll just return, let's say, strongest fort in the world made. Nice and easy, just like that. Let's see if this works. If I create, let's say, Shrek, and Shrek is a new ogre with the name of Shrek. Weapon is going to be a club. And then finally the color, obviously, green. If I do Shrek.attack, or let's just do Shrek here to see what we get. Look at that. I have a new ogre that was just created for me. How awesome is that? And if I do make fort here and run this, look at that. I'm able to use make fort function or method on Shrek. But if I go and do make fort to Dobby, nope, Dobby can't make fort. He's very, very weak. There's not much that he can do. He's just a house elf. So let's go back to attack here. How cool was that? We were able to keep our code nice and organized and extend our base class character to create all these different characters in our game. Elf, we have ogre, we can keep creating different things like knight, magicians, princesses, kings, queens. And we can reuse code that we've written before, but also extend these classes to have their own individual unique things, like properties like type, or even methods like make fort. This is a simple example, but you can imagine the power of this as we get more and more properties and methods and bigger objects. Now let's take a break here and revisit this code in the next video. Bye-bye. In this video, we're going to talk about how to contribute to open source and actually take you through the steps. But first, for those who don't know, what is open source? Well, a lot of technology that has been created on the internet that we know today has been built on top of open source projects. And open source projects means that anybody can view the code. Anybody can see the code of a program, can inspect it, can modify it, can enhance it. In this way, the idea is that by sharing this information with everybody, we get everybody's input and we use the collective mind to improve software. Not only that, but it also benefits everybody, right? For example, the most famous example of an open source project is Linux, an operating system just like Windows or Mac OS, except it's built by everyday programmers. And it's code that is completely open sourced. Anybody can inspect the code, add on to it, and it's become so successful that most of the cloud that we know of, the servers usually run Linux. AWS, Google Cloud, Microsoft Azure, all of them use Linux. Some of you might be running Linux right now as you watch this video. So not only do you get to work with other developers from around the world, where you can build great projects by just working in teams, by learning how open source works, well, you don't have to create something as big as Linux. You can create a project with a friend, something very small and simple. It doesn't really matter. The idea is of collaboration, of openness and sharing code to hopefully improve on the collective knowledge. Finally, a lot of employers actually look upon open source contribution as a plus. So if you're able to put in your resume that you're an open source contributor, well, that's a good sign. Plus, it teaches you valuable skills using Git and GitHub to work in teams. If you're looking for job experience but you don't have a job, contributing to open source is the perfect way for you to learn how to work in teams and mimic a work-like scenario. This is a really important video and something I'm really excited about. So let's show you how to make your first open source contribution. Improve your resume, learn some real-life skills, and have fun along the way. Now, we've actually created some open source projects for you for this course. We have the Zero to Mastery repository here, where we can see that we have about 64 projects open right now with about 2,000 contributors. That's a lot of people, and this number is bound to increase. Now, this place was created as a practice ground for you, a playground. Nobody will yell at you if you break things. You can contribute, add silly things, whatever you want. It's a testing ground. The idea is to have as much fun as possible and make it as easy as possible to contribute to open source. Now, within that organization, we have a great community of administrator or management team that will help you with these open source projects. By the way, who are these administrators? They're right here. Ignore my name. I help out as well, but they do a lot of the heavy lifting. And they are past students, just like you, that have had a bit of experience now. Most of them are working full-time, but they are now helping out the community by helping with our open source projects, our Discord, and generally just helping our community grow. So shout out to them. If you get a chance, say hi to them on Discord. They definitely do a lot for this community. They're very active on Discord, and they really help maintain all of our open source projects. So let's learn how to make our very first open source contribution. I do want to note here that this isn't the only way for you to contribute to open source. This is just a playground that we've created for you. But once you contribute here, you can go off and contribute to all the other open source projects all over GitHub that you can find. You can contribute to projects like React and Angular. The world is your oyster. Or you can just stick to these, as we actually have a ton of projects here that are fun. We have events going on like Hacktoberfest. Well, we'll get to that shortly. We definitely have a great community of developers, and we can create some awesome projects together. Now, the way you want to get started is to first go to the Start Here guidelines. Now, in the Start Here guidelines, and I'll link to this page, you actually have a 4-step guide to get started. The first thing you want to do is to actually watch the Get Started guideline. A fellow student actually created this guide for you to follow the steps that I'll mention in this video. So you always have this as a reference. So after this video, definitely check out this document as a reference. But otherwise, once you've browsed through the document, make your first pull request. So if you've already watched my Git and GitHub videos, you should be all set. Otherwise, hopefully you're familiar with Git and GitHub. Now, the first thing we want to do is to actually add our names to the contributors.md file in this project. So if you go up, you'll see that we have a contributors.md, which stands for Markdown file. And if I click on here, you see that all the contributors that we have over 1,000 contributors. And if you scroll down, these are all their GitHub names. So your first task is to actually add your name to this list. So how can we do this? Well, we can just clone this repository, but a more recommended way of usually contributing to open source is to fork the project. Fork essentially means copy over the entire project and put it on your own GitHub profile. So if I click fork here, and we see over here that you can select where you want to fork the project, and you want to select your profile. So once we fork this project, we make a copy of it. It's like we own this repository now with our own version of the Start Here guidelines. So once we have this, we can clone this repository using SSH or HTTPS, whatever you prefer. In my case, I'll use SSH so that I don't have to use my password every time. I can now say git clone and clone this repository. Now we can cd into start here guidelines, and we can open this up in our favorite text editor. Now, once here, let's clear this. We have the contributors file, which we need to add our name to. Now you can see here the contributors file is getting quite long because, well, we've got a lot of students who are contributing to open source. But at the very end, make sure you're at the very end here, you want to add your own name. Now here's the thing. Right now we're on the master branch, but I'm going to show you what a good practice is. We have our forked project, and we want to create a new branch to work off of instead of master by saying git checkout -b to create a new branch. And we want to name this branch. In our case, let's just name it test. If I hit enter, you'll see that now I'm on a new branch called test. And in this branch, I can add my name to this contributor list. In your case, you'll want to use your own GitHub profile. So we're using Markdown here, which is a syntax to write and have some functionality. For example, if we go to the contributors list, you'll notice that they are all clickable links. So we essentially use the same notation. We do a dash, square brackets with your GitHub username, and then in the parentheses, we just have the actual URL that you want to link to. In our case, the GitHub username that you have. So your GitHub username here, GitHub username here. Once we do that, we can save this file and now go back to our terminal and say git status. And we see here that, yeah, we just modified our contributors.md file. And if I do git diff to see any changes that we've made, we see that we've added this new line. So let's clear this. We have our name all set up, and we can now add this commit by saying git add and dot for everything. We'll add everything, and then git commit, and we'll write a message that says added my name to contributor list. There we go. So now it's time for us to push these changes. Now if I do git push origin master, well, right now what that would mean is that we want to push to origin, and the origin is this start here guideline, which I forked. So the origin is actually my version of the project. And if I want to push to master, that is the main branch. But we don't want to do that because ideally, we want to be able to also change and add our name to the original Zero to Mastery Start Here guideline because this is the main project. So what we can do is instead of master, push to our test branch. So we say git push origin test. There we go. Now, if I go back here and go to my project and I refresh, I now have two branches, the master branch and also the test branch, which I just updated. So one way to do this is to click on new pull request. And you can add comments here like I've added my name to the list, and you can tag some of our maintainers. In my case, I'll just tag myself. If I do create pull request, I now have my pull request. And notice here how my pull request is now at the Zero to Mastery Start Here guideline. So that if I go back to our Start Here guideline, I see that I'm part of the pull request now, right here. And because I've tagged one of the management teams, so in this case, it was myself, or you can tag any of the management team that we have. Now, in this case, I'm cheating because I also help manage this. So I can just myself merge the pull request. Most likely in your case, you won't be able to merge it yourself. But if I click merge and confirm, there we go. I've merged my project. I've deleted the branch and the pull request is closed. If I want, I can even delete my own fork. But for now, let's keep it the way it is. Let's check the start here guidelines and see if my name has been added to the list. If I scroll all the way down, hey, check that out. There's my name on the list. So I've been added to the contributors list. That was pretty easy, right? And the cool part is that now if I go to my profile, I actually have Zero to Mastery as one of my organizations. So if you're able to add yourself to the contributors list, you can actually join the Zero to Mastery organization and have this little icon appear on your GitHub profile. And lots of GitHub profiles have organizations, so people usually have their workplace icon in here. So it's just a nice little thing to have on your profile to show that you're involved in the programming community. So we've just made a pull request, which is step 2, and that was pretty fast, right? Finally, the next step is to go join an actual project and start contributing the way we just learned in our Zero to Mastery organization. Now, there's actually a guide that we provided for you to figure out what project you choose, what's going to be good for you. We also have in our Discord a group projects section where we can look at some of the current projects that are happening, or you can just go to the Zero to Mastery organization and pick any of the repositories to contribute to. Now, in the next video, we're going to contribute to one of these projects and show you a real-life scenario. I'll see you in that one. Bye-bye. Welcome back. We've just done our first contribution, which wasn't that crazy, right? We just went to the Start Here guideline and added our names to the contributors list. But let's actually contribute to an open source project now. Now, in our community, every month we do coding challenges. Now, you can search for coding challenges here, but this month is a special event because we're actually doing a Hacktoberfest event. And this happens once a year in our community in October. And you can see that if we click on the Hacktoberfest 2019 link, so depending on when you watch this, you might have a different year. You see that we've provided for you an opportunity to contribute to an open source project. We actually have Animation Nation. We have a Sanctified project and also a Python project. And you can contribute to any one of these. So if we look at Animation Nation, well, people have contributed their CSS animations here. Ooh, this one looks nice. We also have the Sanctified project. So people have created a little Santa website. That's kind of nice. Very, very cool. And then we also have the Python art project that actually does something really cool. If I go to the website here, it'll actually turn an image into ASCII art, which is really, really cool. Now, there's tons of projects that you can do, but let's try and do this Animation Nation project. So the first thing I'm going to do is go to the project repository and follow the steps that we've done before. That is, we fork the repository. We now clone this repository. Let's git clone. And while that is being cloned, let's look at the instructions. Now, most open source projects will have instructions on how you can contribute. In our case, we have a nice step-by-step guide. So in the art directory, create a directory name after yourself. Okay, that's nice and easy to do. So let's cd into the animation nation project. Let's open it up in Sublime. And we see that there's an art folder. And in here, we have to create our own name or our own folder with our name. I've actually already created a folder called Animatron that has a little CSS project with index.html and CSS. So just to show you, let's move this. Or just to show you, this is my little animation using some simple index.html and CSS. Nothing too crazy. Now, all we need to do is move this into the art folder as the instructions have given us. And now we've added our project. Let's see, where's Animatron? There it is. That's my project over there. Next is to, well, within this folder, make sure we create two files, an HTML file and a CSS file, and link the CSS file to your HTML. Using only HTML and CSS, create a work of art. So I've actually already done that. Again, if we go back to the project, I have an index.html file, very, very simple, that's linked to a style sheet. And this is my styles that I've added for my animation that has these little lines. Now, the last part here is to add my own card to this section, to the include.js file. So let's just copy this, go to the includes or include.js, and you see this is where everybody enters their information. And right here, we can just add what we copy and pasted. Make sure the indentation is proper. So the art name is going to be called Animatron. Page link is going to be, well, the name of our folder. So Animatron index.html. And then the GIF name, which they suggested that we include a GIF. So if I remember correctly, the GIF name was trans.gif. Again, I just created a little GIF of my animation. So we'll call it trans.gif. Author is Andre, and the GitHub link is my GitHub link. All right, so that should be good. Let's now make a pull request. Now, notice here how I did all these changes on master. Ideally, we created these changes on a new branch. So we can actually just do that now. Git checkout B and call it Animatron. So if I do git status now, I see that I have two changes. That's good. Let's do git add, git commit, adding my artsiness to the project. And then finally, git push origin Animatron. All right, if we go back to the project, we see that we actually now have a little icon that says compare pull request. If I go back to the forked repo, 0 to mastery, you see right over here that I also have this yellow banner. So if I click on this and say, please add me to this list, and we'll link to, this is Joy, who's one of the managers. So I'm just going to say, please add me to the list. We actually don't even need to tag her because she will check this occasionally. So I'm going to create a pull request. It's now opened. That's awesome. So please add me to the list. If I look at my file changes, you can see that these are what I've added to the project. So if I now merge pull request, again, you won't be able to do this, but some of our management team, people who are managing the open source projects, will be able to merge for you. We can delete the branch since we have merged everything. And now let's see if the changes have been made. If I go to the Zero to Mastery Animation Nation, so if I now look for my project, hey, look at that. There's my little animatron project that, well, there it is. There's my CSS. That's beautiful. Now, the way this project is designed, it randomly selects the CSS animation. So it might not show all of them at the same time, so you might have to refresh this a few times. But just like that, I made my open source contribution. Now, there's a ton of projects here that you can join. And like I said, this is a playground for you to test, make mistakes, because this isn't a real workplace. We want to practice these skills before we actually go into work and make big, dangerous changes. And that's open source. I highly, highly recommend that you get involved. It's a great way to work with others. It's a great way to learn how Git and GitHub really work. There's no doubt that there's a lot that an individual programmer can do. However, the progress and scale that something can be built is really compounded when many people work on something together. Go make your first open source contribution and have fun building things with your fellow programmers. It may one day lead you to impress a potential employer. See you in the next one. Bye-bye. Hey there. I wanted to take a second at the end of it all, at the end of your learning journey, to just say this one thing, and that is, thank you. I know your time is valuable. We have limited time on this earth, and you decided to spend your time and your money, frankly, with us, doing something that takes a long time to learn. So truly, from the bottom of our hearts, I know it sounds cheesy, but thank you for dedicating your time and effort to this course. I hope you got what you wanted out of it, and congratulate yourself for getting this far, because a lot of people start, a lot of people have hopes of learning, but they give up along the way. But you didn't do that. You worked through the challenges, the problems, and you got here. Now, your learning journey doesn't end here. It keeps going. But I hope this created a foundation for you to go off and learn things on your own, get a promotion, get hired, start a new business. Whatever it may be, again, thank you and best of luck with your learning journey. This is just the beginning of whatever you decide to do in the future. So thank you and good luck. Hey there, this is my face, Andre. I'm usually sitting in front of a computer, not in front of a camera, which I'm not comfortable with. But this is the AMA video, and wow, I want to just absolutely thank all of you, because we have officially hit 100,000 unique students, which is insane, absolutely mind-blowing. I did an AMA video when we hit 1,000 students, and I thought that was just extraordinary. And to be at 100,000 now is absolutely incredible. I feel extremely lucky. I feel extremely blessed, and not to get too sappy here, but I'm very, very thankful for you watching this video right now, because I don't really do any marketing, and it's all grown out of word of mouth. So thank you for telling your friends, your family, your kids, whatever it is. I am extremely thankful that I get to do what I do, and it's all because of you. All right, so no more sappiness. Let's get to it. I asked you on Discord some questions that you might have for me. there were a lot of questions. Unfortunately, I won't be able to answer all of them. I don't want to make this into a boring 1-hour video. So I've picked the ones that I thought had a lot of people interested in them, and hopefully I can give you some answers. Keep in mind that you should form your own opinions and decisions based on these. This is just one person's view, my view. It doesn't mean that I'm 100% correct. If I thought that, then I would have a YouTube channel. But take it with a grain of salt. These are just my opinions. I may be wrong, I may be right. It's just what has worked in my life. Doesn't necessarily mean that it will work for you or the answers are right for you. All right, let's see. First one here. We have Nick Solar, who asked, what's the best way to get into machine learning and artificial intelligence? That's actually a question that kept coming up. A lot of people are interested in machine learning, data science, anything related to AI, because it is extremely popular and a hot topic right now. I actually have a course coming up on it that tries to tackle that question, because machine learning right now, it's a bit of a buzzword where it solves all your business problems, when in fact, maybe it's not necessarily so. And I think there's developer interest to learn about machine learning, as well as business analysts and business decision makers to use machine learning and data to improve their profits and their business. So I didn't really give you an answer for that one, but it's one of those topics that I think in order to learn about it, you should at least learn to code, become a web developer first, or perhaps have some understanding of business data analysis before you get into it. All right, next question is from NK. Talk about your life as a developer from start until now to learn from you. Well, I think some of you know from my previous MA, I did not come from a computer science background. I came from a business background. I did also a minor in psychology and learned to code in my 20s. I'm 33 now, by the way. Hopefully I don't look 33, but that's my age. And yeah, I would break down the developer lifecycle into 3 phases. So the first one is where you're just learning. You're learning to code. Everything is completely new. You feel extremely overwhelmed. You don't know what to learn, what person to trust, what mentor to have, what course to take. That's a really big challenge, and getting to the point of understanding and being able to build something from scratch yourself. I think that's the first phase. The second phase was when I was employed for the first time, and the first couple of years working as a developer, where you feel the imposter syndrome, right? Where you feel like you just don't know enough, or somehow they hired you by mistake and, well, everybody else around you is smarter than you. That phase really goes by. The one advice that I have for that phase is to honestly be comfortable with being uncomfortable. That is, ask as many questions as you want. Don't feel like by raising your hand and asking a question, it's going to make others look at you like you're dumb or not good enough. The more questions you ask, the better you'll have the answers, and you'll find that the successful people through this phase are the people who ask a ton of questions. When they don't understand something, they try to learn and try to grab as much experience as possible from those around you. And then the third phase is when you start to become a little bit of a senior developer, when you start to get confident in your abilities. You perhaps start to lead projects, perhaps other junior developers look up to you and ask you questions. One of the biggest things with that phase of a developer is to not almost get a God complex, where you feel like your opinions are the right ones and everybody else's is absolutely wrong. I've seen way too many really good developers get overconfident in themselves and have really strong opinions where they don't take anything else into consideration. I think through that phase, if you're able to understand that everything has pros and cons, everything depends on the situation, and that you're not, oh, I only use GraphQL, oh, I only use TypeScript, and dynamic languages are trash. When you avoid those strong opinions to almost make yourself feel like you're smart, you're doing something wrong there. You want to be open to ideas, open to suggestions, and not forget to keep growing from that phase, because as you start to get more and more recognition, maybe you feel more confident, it's very easy to think that you've reached the pinnacle and you need to stop learning. This whole industry is all about learning and constantly evolving, and what you know 2 years from now will probably be different than what you know now. So those are the 3 phases, kind of the ones that I went through. Obviously, I'm teaching now, but for me, learning doesn't stop. I'm constantly learning. I'm constantly trying to improve myself, both in teaching, but also as a developer. And I hope that that is the case with you as well. All right, next question. Next question is from SG. How many countries have you visited during the last year? Any suggestions to travel while working remote? So for some of you that don't know, I work completely remote. I carry my recording equipment online, and I set up my studio wherever I am in the world. So my courses have been recorded in Ecuador, in Nicaragua, Colombia, in Greece, in Romania, pretty much anywhere that I'm traveling. I bring my recording equipment, set up my little studio, and record. So last year I traveled to, I would say, about 7 or 8 countries where I lived in them long term. My favorite was I actually recorded the Master the Coding interview course in a little house on the side of a volcano in Ecuador. We're the last house at the very top of the volcano. So we had to hike down and grab groceries every time we needed to eat or wanted to cook dinner, and hike back up with all our groceries. That was a lot of fun. Any advice for remote? Honestly, it's one of those lifestyles that it sounds nice, but it also requires a lot of dedication and commitment to work, instead of just not being committed to a schedule and making it really easy to go off and pretend like you're busy without actually accomplishing anything. So you do need to have a bit of structure, but for those that are self-motivated and determined enough and can keep track of tasks and don't get distracted often, it's definitely a lot of fun. All right, this next question, I think I got asked maybe 5 times from people like Dorjan, Shupar, Scramblelock. All of them essentially said, why did you quit your full-time job? How come you're not a developer anymore? Well, let's say that I'm still a developer. I do a bit of consulting work on the side. The reason that I quit my developer job was mainly because I wanted to travel a bit and take a break. I had spent a couple of years working for other people and working on projects that perhaps I didn't care too much about. I was working for other people's passion projects or businesses, and after a while that kind of gets old, or at least it did for me, where I found that I stopped learning as much. It was just repeating and doing the same thing over and over. So I decided to quit and kind of figure out what I want to do next. And along the way, I decided to record some videos, my first course, Zero to Mastery, to just keep myself busy and keep doing something and help people who were like me, where they didn't have a CS background and wanted to get into web development, but there wasn't a clear path for them to do so. So I recorded that course, and it took off, and all of a sudden this became my full-time job. And now I would 100% still go back to being a full-time developer, but I'm having so much fun teaching. I still get to code every day. I still get to learn every day. And if anything, I think this way I have a bigger impact on people's lives than I did when I worked on a single project. So that's why I quit my job, and at the end of the day, it was one of the best decisions I ever made. I have another question here, which is, what is my biggest regret? I feel like I'm in an interview right now, so I'll give you my interview answer in case you ever get asked this in an interview. So my biggest regret, honestly, there's nothing. I'm really, really happy that I learned coding when I did, in my 20s, and not when I was young. Because when I was young, I was able to learn different skills. I was able to learn about business, about psychology, about communicating with others and people. And those skills helped me get my first job as a developer. Although maybe I started to code when I was a lot later on in life, it's not like I didn't do anything before my 20s. I was learning different skills. And for those people that perhaps are thinking, am I too old to learn to code? Or I'm in my 30s and there's people, in their teens that are learning to code right now, there's no way that I'm going to be able to keep
keep in mind that most likely you have skill sets that other people don't. And when it comes to regret, honestly, there's nothing. As long as you're learning every single day and learning something useful, over the years, that's going to compound. And honestly, every single mistake, every single decision that you make leads you to where you are now, which sounds a little hokey pokey, but it is true. Honestly, there are no regrets. If you're learning, you're never going to have regrets in life. All right, Yex, how's it going, Yex? Asked me what annoyed you the most about being a developer. I usually don't get annoyed. I'm pretty easygoing. But the one thing that I did notice was that as people get more and more experience, they tend to form really strong opinions. And everybody wants to feel like they're part of a group. And I think we see that a lot on Twitter and YouTube, and all these people with really strong opinions that kind of gang up on other people that have different beliefs than them. I think it's very easy in the developer community to have something like that, where you're thinking, my React team is better than your Angular team, or TypeScript and static typing is the way to go, or REST is dead and let's all use GraphQL. I think when you have that type of mentality, it's really, really hard to actually have smart discussions and decisions within a project. It becomes really, really easy for those who feel superior to others and feel confident in their opinions to really impose their opinions on others, especially junior developers that are susceptible and have less experience, so they start to believe these senior developers that perhaps have really strong opinions. And in turn, that kind of creates this wave of more and more people that think it's a good idea to have strong opinions and debate with others and argue with others and telling people that their code sucks and their code is the right way of doing it. I think that was a little bit annoying to deal with because I think it influences junior developers a lot, and I don't think it's a good attitude to have when working with others. I think being somebody senior, being a lead, being a project lead, it means you're a person that doesn't put other people down, but it lifts others. And that was a little bit annoying because I saw that was a little bit prevalent, where everybody's trying to almost outbeat each other and be a better developer than this person and this person, instead of all of you growing together and learning together, because there's enough developer jobs for everybody. You don't need to beat out everybody to be the number one developer. So that mentality was a little bit annoying to me, but then again, I worked in Toronto and Silicon Valley, and I think those areas especially have really, really strong individualistic philosophies. All right, this is another question from DH. From where and how did you learn and become a developer? So when I started to learn to be a developer, I probably spent, I would say, $20. I think I bought a book on HTML and CSS, and the rest was all online for free, just using online resources. The only difference was that when I started to learn, there were very few resources online. I think I used one blog post that told me to use Photoshop and GIMP and some tools that I actually didn't even need, but it was really hard to find resources online when I started to learn. So I essentially just try to grab as many resources as possible and create my own curriculum, but it's not like it is now. I think right now we have a lot of resources online. It's a lot easier, and there's more of a clear-cut path to become a web developer. So I'm a little bit jealous, but I also did the same thing that you probably are doing, which is watch a lot of online courses, read a lot of books, read a lot of articles, and most importantly, building my own projects and coding as much as possible. That nothing beats actually coding. You can watch videos all day, but if you're not doing anything, if you're not producing anything, it's like watching a tennis match and trying to become a better tennis player. It's just not going to happen. We have Jamie who asked, what's the best way to practice code? Is it good by imitating someone else's code for practicing? Again, goes back to my last point. The best way to practice code is to code. The more you code, the more you practice, the better it is. But keep in mind that the best way to code is to solve your own problems, create your own projects. I actually don't recommend just watching all my videos and following along without coding, because then you're not going to be able to do things on your own. The best way to code is to code by doing your own thing. You can watch 100 videos on people coding and follow along, but if you don't understand why we're doing things, then when you're left to your own device, you're not going to be able to do anything. So the best way to code is think of a project today, think of a task that you have to do over and over in your life, and see if you can automate it with code. That's the best way to learn. Ty Lim asks, what is your favorite tech stack? My favorite tech stack is the one that lets me accomplish my goal as fast as possible. That's a very vague answer, but honestly, anything that lets me finish fast and deliver something fast is my favorite tech stack. Because I tend to work by myself or in small teams, I really prefer things that are efficient. So for example, I'm not a big fan of TypeScript, because although you get type safety and static typing, it's a lot of extra code. It's the same reason that I personally am not a big fan of Java programming, not because it's not a great language, but because for my personal use cases, I'm not working at a big company with thousands of developers for, let's say, a financial institution. If I'm building a personal project, I'd rather use something quick and easy like Python or JavaScript to write a few lines of code and accomplish a goal. So there's really no favorite tech stack. It's the stack that allows me to accomplish the goal the fastest, which happens to be usually dynamically typed languages, and usually the languages that I'm comfortable with. I don't need to learn something